Okay. Uh, your proteges. Oh, sure. No, I can do that. Okay.
Top.
You should totally hint if it has to be written. Anything else is cool.
Yeah, they're going to be mine's on.
If anything, until I get this fixed, I know.
Use it. It's fine. I can use the handheld.
And then I'll come in and let you know when
Good
they
for
turn
when
it
we,
on.
you know,
Unfortunately, I can't do anything on this end.
it's totally. Hello.
Hey. Come on in. Yeah. Oh. No, there was issues with. I mean, we're okay, but there's issues with the other lav mic.
I can use this one though. It's fine. Okay, sure. I'll Oprah it anyway, so it's fine. Like.
Oh, do you want to go?
Oh,
yeah,
excellent.
here. Sweet. Sure. Yeah, Kelsey's next door. He's gonna have the bigger crowd, so you're good right here.
Hey, so my name is Karthik Bharath. I'm a pre-sale solutions architect with Tigera, the creators of Project Calico. A few of you might be familiar with us. We're one of the first and continuing open source third-party CNIs for Kubernetes. Today, I can kind of talk a little bit about where we fit in the Kubernetes landscape as kind of the agenda. Is that fine? Yeah. Okay, cool. Yeah, yes, we're doing this because we're a sponsor. I think that's the important thing. But with Calico, you kind of get networking, observability, and security kind of out of the box. You already get the networking use cases with CNI. It's a layer 3 CNI. You can BGP peer your worker nodes to upstream, advertise your pod siders, service siders, and all of that goodness. We also do a egress gateway solution that's a pod-based egress gateway solution, so you don't need node access and VIP as a layer 2. We do it at layer 3, and you can kind of scale that. We also recently just added our version of an ingress controller that is basically based on the Envoy Gateway API spec, and we're going to continue adding kind of enhancements to that. We're also doing multi-cluster networking through establishing essentially our VXLAN overlay, extending that to multi-cluster. As long as you have the underlay routing done, we can do the overlay routing for you as part of the Calico cluster mesh as a layer 3 solution. In addition to that, we're still committed to kind of furthering the open source. So some of the observability is going to come soon, TM, to Calico. A lot of that observability today is in enterprise, but you will be getting a version of that in open source as well. So yeah, check out Project Calico. You can put it on your clusters at home, bring it into work, and if you do want to bring it into work, you can reach out to us and have a further chat. So yeah, thank you.
Thank you. So as you guys can tell, we're in the warmest room ever, but we do have some beanies to give away with some audience participation. So yeah, bear with us in this Siberia room. Okay, let's get started. So.
Oh, I'll introduce myself. Hi, I'm Catherine Druckman. I am an open source evangelist at Intel. I also am involved in a few different open source organizations. I co-chair the OpenSSF DevRel community and the Marketing Advisory Council. And most recently, I am leading the OPA Security Working Group. OPA is Open Platform for Enterprise AI. I would love to talk to any of you about that if you're interested later. Find me, and I like to describe myself as a recovering software engineer.
All right, so Catherine's way cooler than I am. My name's Lori. I am the head of community at Percona. That is a picture of my little family, my daughter Lola, my dog Luna, and yes, I'm Lori. There's lots of L's in one household. As you can imagine, it gets confusing at times. I'm a CNCF ambassador, a CDF ambassador, OpenSSF DevRel committee member, platform engineering ambassador, blah, blah, blah. I do a lot of stuff in the community, and I'm super happy to connect with you on LinkedIn or anywhere on these other little channels. And one of my favorite things is connecting people to other resources and other people within the community, so please do not feel afraid to reach out. I'd be super stoked to help you.
Me too. Likewise.
So here's a little bit of our agenda. So this talk is called, well, what is the talk called?
The Hitchhiker's Guide to the Cloud Native Landscape.
Right.
Why do we call it that?
Because what?
Oh, yeah, Hoop Fruits. Yes, reference to the...
Okay. Anyway, so we're going to talk about the history of the CNCF, why the landscape is important, how to use the landscape, awesome projects you may not know about, and what's next. So before we begin, is anybody here a part of the CNCF currently? Okay, so you get a hat, and you get a hat. Those hats are Valkey hats, which is a part of the Linux Foundation, not CNCF, but swag is swag. Okay, great. How many of you think your companies are part of the CNCF and you just don't know? Okay, this is something to look into because the CNCF has lots of benefits to its members. So ask your OSPO, ask your head of marketing, ask somebody, because we're going to go through some of the cool things about the CNCF, and you don't have to be a member, but if you are, you could be losing out on like free trainings and all kinds of good stuff. So this picture was taken at the 2024 Kubernetes Contributor Summit at KubeCon in North America, and as you can tell, there's tons of people there ready to roll and talk Kubernetes. And so what is the Cloud Native Computing Foundation, and why is Kubernetes essential to us? Well, CNCF's mission is to make cloud native computing ubiquitous, and it started with Kubernetes, which we'll get to in a minute. Currently, there are 208 projects. There are 250,000 CNCF project contributors. You may be one in this room. There's 756 CNCF members, which is why I'm saying check your company to see if you're one of them. And there's over 96,000 cloud native community members. So what does that mean? There's 96,000 people continually working with the CNCF to further our mission, which is to make cloud native computing ubiquitous. Anything?
I would just add that the main goals really are multiple, right? It's not just about fostering the landscape and supporting these projects. It's also about fostering the community. And like Lori said, taking advantage of these growth opportunities, which they provide.
So one thing you might not know is that the CNCF is under the umbrella organization called the Linux Foundation. And so the Linux Foundation, we're all at SCaLE, we all know Linux, is responsible for 900 open source projects, 3 million developers. You can read the numbers. I mean, it's huge, it's insane, and it's part of why we're here today. So Linux Foundation, CNCF, and a bunch of other foundations underneath that.
So many.
So many
There's one
foundations.
for everyone.
But let's talk about the history, and this is actually the 10-year anniversary of the CNCF. So how did the CNCF begin? So in 2014, Google partnered with the Linux Foundation to create an organization to foster cloud-native solutions. This was because of a project called Borg. Borg was then
It's like
renamed.
a trivia question, by the way.
Oh,
You will get asked this in some nerd trivia. And what was the original name of Kubernetes? And that is the answer, so you're welcome.
does anybody know what was the original name of Kubernetes? Yes. It was Borg.
Yes.
You get a hat. So close. Sweet. See how easy that is, guys? Okay. So with the creation of, or wanting to create a foundation, it took a year, and then 2015, CNCF was founded. Now, if you want to look at some fun stuff, you can go to the CNCF GitHub page and look at their charter, and look at all of the things that are required to be a part of the CNCF, and all of the things the CNCF promises to do to the community. It is a lot, and it is pretty amazing the way everything is open seat at the table, all of the code of conduct things, everything that is a part of the CNCF is chef's kiss.
And no organization is too small.
Yes.
That's the great thing. You can get in a room with leaders from organizations of all sizes, all the way from, the big guys to the startups.
Percona, Intel. There you go. So 300 people, how many?
A gazillion.
Yeah, so they're, aw. Okay, 2016, Kubernetes officially joined the CNCF, so we had a name change, joined the CNCF. Now, this is a thing that I find very interesting that you guys might not know. So in 2016, we had one project, followed by two others, Prometheus and Envoy. So 2016, 3 projects. By 2018, we had 31. And Kubernetes is the first in a graduated line, and we'll go over the process to get to graduation for a project. By 2020, we had 80 projects, 14 of which were graduated. 2024, over 200 projects, 26 graduated, and last year, Kubernetes celebrated its 10th anniversary. And then this year is 2025, it's CNCF's 10-year anniversary, and we have 31 graduated projects, and we are still counting. It's only March.
Yep.
Do you want to go over there?
Sure. So we'll take you a little bit through the adoption process, right? How does a project come under the umbrella of the CNCF and go through to hopefully eventually become a graduated project? So there are a couple things, right? So depending on the maturity level of your project might enter after the application as a sandbox or an incubation stage project. And really those have to do with maturity level is things like the diversity of contributions, right? How many companies and how many individuals are contributing? What's the adoption? That kind of thing. And how mature is your community? Are you getting a lot of pull requests? Are you getting a lot of contribution? And so each stage is kind of defined by that type of maturity metric. A graduated project, of course, is likely to have been around for quite a bit. It might be adopted and heavily used in production, with companies and people all over. Things like, think of Helm or Kubernetes itself, things that are kind of ubiquitous in the software landscape. And they've probably been around a long time. But the most important thing, and I think I like to talk about this also from a security perspective and just a general best practices, is that you have those contributions from at least 2 organizations, but preferably more. In the case of something like Kubernetes, you're going to have a lot more organizations because it is mission critical. All of this stuff really is mission critical. So yeah, anyway, that's basically the process in a nutshell.
And when I say check out the CNCF GitHub for more information, if you're looking to submit your project for adoption, the amount of, I call it a marathon and not a sprint, the amount of check boxes that you have to tick off, I mean, it is insane. But it's all so that when the TOC determines if they are going to accept you, they know that you're in it to win it, right? They know that you're not just trying to donate a project and then abandon it. Like, there's a lot of rules, there's governance models, there's lots of things that you have to do. So when a company decides to donate or try to donate their project to the CNCF, it is a marathon and not a sprint, and it can take up to a year because you have to keep going back and forth and doing your due diligence to make sure that you're making everything the way it needs to be.
And then what does it mean as a user, right? When you're here, right, because you're here thinking about how to evaluate projects that are part of this landscape. So when you're a user and you go in and you look at the various stages, what does that mean to you? Does it mean you shouldn't use a sandbox project or you shouldn't get involved? No, it doesn't mean that. It just means, again, due diligence. But I would say definitely if something is graduated, you can feel pretty solid that that's a well-supported project.
And just so you guys know, I have my speaker notes on my phone. I'm not like just like not paying attention. Tip, if you're a speaker, use your phone, it's great. So here's something that I think is really interesting is the project count over time. So currently we have 129 projects in Sandbox. Now Sandbox is the green area, and you can see that's the biggest area. We have 36 that are incubating, and then we have 31 that are graduated, and that little gray line is really important, and those are ones that are archived. Now, why does a project get archived? Well, either somebody created another project and that project became null and void, they lost their maintainers. There's tons of reasons as to why something can get archived. But if it gets archived, it's not necessarily dead, it's just not being worked on currently. Yeah. But one of the things, the reason why we thought this talk was so important is the number of Sandbox projects, 129. So there are 129 projects that you probably don't know very much about that could be helping you in your day-to-day, which would also help them get to the next level of incubation, right? So we're all a part of open source because we like to innovate fast, right? We like to break things, we like to make things, we like to see what's going on. And I think part of this talk is to kind of help you look at the landscape to see if there's some tools out there that you might not be using that might be very beneficial.
And it's over half of the landscape, too. They're in Sandbox.
Yeah.
So that's something interesting to remember.
So one of the things that we always get told is to go to the website, but like going to a website, like where do you start? Okay, so I went to a website, what does that mean? So if someone told you to go to the CNCF landscape, like what, huh? I'm sorry.
Just go build your workflow.
Yeah, just go ahead and find your workflow, like you got this. Like, I'm sorry, what, huh?
Ah, yes, one of my favorites. So this is the nostalgia slide. This is the cloud-native landscape as it was in 2016. Quite a bit smaller. Back then, this kind of layout, I mean, even though it's frankly a little overwhelming even in this stage, because there are so many projects to choose from when you're building your applications and your pipelines and everything. But it is a little bit more manageable. And so, you can see from 2016 to now, the growth has been explosive. And in its current state, it is, again, a whole lot more difficult to manage. So it requires some dedicated effort to even learn about these individual projects to try and figure out not just where to start, but what to include, what not to include, what to avoid, what fits your use case, the status of each of these projects. If you wanted to look at each of them individually, I mean, what are you going to spend the entire year? Anyway.
Yeah, there's a lot. So our buddy George, who was in here earlier, who has since scooted out, is one of the people that are responsible for how the CNCF landscape looks now, which is so much better than it did before. One of the things that you can always do after this talk is go to the guide button, and the guide button kind of breaks down what the individual sections of the CNCF landscape means and gives you the projects that are within those. So if you're looking for anything under container registry, this is what it tells you, and then here are the ones that are a part of the container registry. But another thing you can do is just go and filter. And this used to not exist, guys. And so this is freaking huge, right? So you want to look at specific CNCF projects. We don't want anything that's archived, right? Because we want something that's actually working. Do we want something that's sandbox? I don't know, depending on the maturity of what we're trying to do with our job. Maybe we don't want to take a, quote, risk and use a sandbox project. Maybe we want something that's being used a little bit more heavily. So we want to go either incubating or graduated. Let's see, what are we looking at? Are we looking at security? Are we looking at runtime? Someone tell me what we're looking at.
Who wants to pick a project? Okay.
T-shirt.
runtime. Boom. I'm not going to throw it at you because I'm a terrible thrower. and
Okay,
I'll
so we
miss.
want to look at runtime, and let's just use that as our criteria. So we went from insanity to drill down. These are only products and projects. So all of these are projects within the CNCF that are within the graduated and or incubating stage that you are looking at that work through runtime. We've got scheduling and orchestration, automation configuration, and container registry.
Fabulous.
So from that, you can then filter down more and use what you want.
Yep. I like it.
Okay. Let's go back. So now we're going to talk about some projects that you might not know about, and we're going to use the landscape to help us figure out a little bit more about who they are and what they do. So we're going to start with CubeScape. And yes, we used AI to make these slides, so don't look too heavily at the icons that make absolutely no sense in terms
I kind
of.
like the Golden Gate Bridge.
She
vibe.
likes these now, but I don't think she's looked at the rest. Okay, so anyways, so what is CubeScape? It is an open source Kubernetes security platform. It has risk analysis, security compliance, misconfiguration scanning. It saves time, effort, and resources because it does it all for you, and it supports CI/CD clusters and IDEs. But let's get into it. So I went ahead earlier and got us straight into the CubeScape card from the landscape. Why are these important? Because this tells you about the health of the project, right? So you can see that it's got 10,000 plus stars on GitHub, vanity metric or not, it still has them. It's got 153 contributors, which I feel like is super important, right? The first commit was in August of 2021, and the last one was February of this year. So you can already see that this project is gaining momentum. It's got contributors, it's got lots of stars, it's got lots of usage. Look at the participation stats, like look at where they're at in terms of like funding. But what I think is like super cool, and I'm not really a fan of the name because I feel like I say it wrong, is Clo Monitor. So whoever made this tool, like thumbs up to you. And this is something that I think that when you start like researching projects, you really should use. And so it gives you the health and a bunch of different score ratings of the project, right? So it shows you like your repositories, it shows you where you're at with documentation. The cool thing is you see these check marks, so you know that they're passing. Whatever level it is for licensing, best practices. Ooh, community meeting, that's like a no, like what's going on there?
Improvement.
Yeah, exactly, room for improvement.
There is no perfect project.
There's no perfect project, but there's also things that you can then as a contributor say, oh, maybe I want to work on signed releases within the security feature of CubeScape, and I see that they need help. So look, now I can contribute. There you go. And so 100% on the Helm charts. Like, the thing is, the landscape is insane on its own, but then it gets more insane the more you go. But what does it do for you as a developer or someone that's like trying to determine your architecture? It gives you all of this information so you can make good decisions up front, but also you can tweak and move and shake because you can compare things to each other. So it's just, to me, I think it's just phenomenal.
I would add also that this is a very high score. So there's scoring a project in general can be a little bit controversial, whether it's the Clo Monitor score, whether we're talking about the cloud native landscape, whether we're talking about something like OpenSSF scorecard. Again, assigning a score to a project based on various metrics. It shows a lot of the story, but it's not the whole story, which is why we want to get back to really reinforcing the due diligence. Now, what we're trying to do here is help you shorten the process a little bit of that due diligence, but that doesn't mean you don't still have to do it. You really do need to kind of investigate the projects that you're using just to see, how they fit in with your own the standards that you've set for yourself and your organization. And things like, again, the latest commit, so important for so many reasons, right? You want to stay on top of things like security issues and all of that. So it is really important to get a full picture. But I do want to say that this, again, is a very high score. And if you get maybe a little bit lower score, does that mean you shouldn't use the project? No, not necessarily. It just means you need to, again, investigate further.
Who uses Helm?
Yes!
Oh, wait, did you already get a hat? Oh, I can't do it. Who else uses Helm? Okay, this guy right there has not gotten anything. All right, you ready? Like, I've got like an arm.
She can do it.
No, I don't have a good arm. Sorry.
No, it was solid. It was solid.
So I think when we're talking about scores, let's look at Helm. So
Helm is doing well.
We just saw what a project none of you heard about is doing. Now look at an 86. To Catherine's point, a project that is graduated, widely used, all the things. Widely used. It's an 86. Doesn't mean don't use it. It just means use it with your eyes open.
But you know what it might also mean? So if I can get on a sandbox just for a little bit about Helm. Helm is it's a fantastic project, right? It's one of those wonderful things in your developer workflow that kind of goes unseen because it's so good at what it does that you don't necessarily have to think about it. You might even take it for granted, which is something that you absolutely shouldn't do with projects that you're using, is take them for granted. Because all of these things are, again, I like to say, as I said before, mission critical. The software that we use, software like Helm, Kubernetes, it runs the entire world. And if we don't keep it going, who is going to do it for us, right? So this, I wanted to say about Helm in particular, because I'm a big fan. I'm a big fan of the community and the maintainers and the people who work on it. But now, this year in particular is a really fantastic opportunity to dive in and get involved. You know, make suggestions. You can actually potentially impact. We're at a bit of a point of inflection. They're gearing up for Helm 4. This is a great time to go in and influence that project, to make sure it's on track to do the things that you want it to do, that are going to solve your use cases and all of those things. Because again, just because it's a fantastic tool and it doesn't bug you and you don't have to worry about it, doesn't mean that you shouldn't worry about it, right? You shouldn't step in and, okay, maybe it has a 84 and 86 or whatever, or even a 75, who knows, at any given time. That is, any of those gaps are an opportunity to step in and influence, contribute, make your voice heard.
And like, here's a good win for you or your company. Like, are you an adopter of Helm? Get your company listed. Go to the GitHub repo, go under the adopt, and go ahead and submit yourself, right? Like, that's something that they're not doing well at, because again, to Catherine's point, people use it, it doesn't bug them, they don't think about
tools.
what they need to do for the project itself. So like, again, an 84 doesn't mean it's terrible, but you can actually see like where there's opportunities for you to help make an impact and help them maybe get their score up a little bit.
Actually, 84, 86, whatever, those are still pretty good scores. It's green, you know.
Oh, that's why.
It's a little slow.
Well, no, it's user error.
Argo.
How many people yes?
Yeah.
Hold on. We're going to throw the mic at you because it's being recorded. Thank you.
Hello. There we go. So I had a quick question about the scoring. So how often is the score updated for graduated projects, or is it updated daily? Is it like a live tracker, or is it reviewed like monthly, or?
No, I think it's fairly live.
I can't take this off my face.
I actually don't have an exact answer for you. I'm pretty sure that it's updated quite frequently on a regular sort of, cron job situation. But it is, it's not like, you have to wait a month for a new score. I'm fairly certain. It's pretty frequent, but I can't tell you exactly how frequent.
The graduation criteria is super crazy. Okay, so you can submit something for graduation in January and not graduate until November. And in that time, you have to go back and do all of the things that maybe you thought you checked marked on a list, and then the TOC said no. The other thing is there's a waiting list. The TOC, so the fact that we have 200 plus projects, we didn't scale our TOC the way that the projects have scaled. So that is something that the CNCF is working on, is how can they also move at the rapid pace to get things graduated, to move people or move projects further along, because projects are wanting to move along and then they realize they're at the back of the line. There's like a bunch of people in front of them and then they have to continually redo everything that they're submitting. So we're having growing pains just like everybody else, but that's another reason or opportunity for you to get involved and see what you can do. And yeah, I'm sorry we don't have the, when this is updated, but we
there are
will
a lot
definitely.
of automated checks going pretty frequently.
And I'll go ask George and we'll find out and we'll get back to you.
And
so link in with us.
Doesn't this use things like OpenSSF scorecard? Isn't it in there? There are a lot
Under
of different
security,
metrics
yeah,
that it's
there's
using.
a lot of different things.
So yeah, a lot of those are going to be on, automated workflows.
And I know this is a CNCF talk, and we keep talking about OpenSSF scorecard, but if you haven't gone to OpenSSF scorecard and looked at their badging, and you have GitHub repos, and you have your own project, I highly recommend you go to OpenSSF, go to scorecard, look at their badging. You'll see even like a project like Postgres is only like 90% of the way completed to getting their badges. And like that's another tool that you can use to see like, is this project, quote, secure? And it does the same thing. You can click on it and it gives you like where they're at. So
it measures a lot of the same maturity level stuff, like a number of diversity of contributions, frequency of contributions, licensing, a lot of the same stuff here, right? That's represented. And also I wanted to say, OpenSSF also is another Linux Foundation project, so we're cousins, so it's all good.
yeah, we're kind of siloed, but yet trying not to be.
Yeah.
Trying to like open source project to open source project, foundation to foundation. So
and yet another foundation and project that would love contribution.
She's heckling for them now. Okay, anyways, Argo. How many of you use Argo? We got one in the back. You raised your hand. You want a shirt?
Excellent.
You get a shirt. Yay!
I will bring you a shirt.
Thank you.
While we're talking.
I
love Argo, by the way.
Argo, super popular project. It's got a 97 score. Again, it's a 94 overall. But this is just something that you should just look at, and then you can feel confident, and you can go back to your manager, your CTO, or whoever, and say, like, look, this is what's up. But they don't have their roadmap documented yet. So we're going to go sit in on a meeting and see, like, what are they talking about, but why haven't they documented it yet? Like, so that we know where the project is going, that kind of stuff.
Argo, yet another project that is so great, it's ubiquitous, and you may not think about it because it doesn't bother you. It's a great project. It made a lot of progress and is constantly making more. But that doesn't mean they don't need your help.
Very active community that could always use more. So here's a new one: Cloud Native PG. How many of you are in the Postgres space? Nobody. Well, you got a little shakiness. Okay. So Cloud Native PG is an operator that has just been submitted is in a sandbox stage of the CNCF. One of the things that you want to look at when you have a new project is always like who donated the project and like how reputable are they? Is it two guys in their basement in Canada, or is it a company that is looking to get more information? And because they're so new, they don't even have a Clo Monitor score. But what you can do is you can see like their contributions, all those things, and then just go to their GitHub, right? Go to their repo, see what's up. Like they've got, like you can go to their, all kinds of things, like how to contribute. You can see who is a part of the project. You can see like how you can become a actual contributor, all that kind of stuff. So when you look at a sandbox project, don't get scared because it doesn't have the same amount of detail as something else, but this is also where you can kind of do your due diligence and say, all right, we do need an operator, we do work with Postgres, this operator is supported by EDB, what other companies outside of EDB are contributing, like who is working on this full time, and if you can't find it in the GitHub repo, check out one of their meetings, right? As a CNCF project, they have to have public meetings. Everything is supposed to be out in the open as open source is supposed to go. And so that's a great opportunity for you to kind of get an insider access to what's going on.
I would also add, again, just because it doesn't have a score yet, or it's not, it doesn't have something that's easy to kind of quickly glance at, there are plenty of things you can do manually, right, to evaluate these projects. Go in, like she said, to the GitHub repo, but look at the commits yourself. Look at who's actually contributing. Look at the issue queue, right? Look and see when the last time somebody replied to an issue was. Let's see the amount of time it takes security patches to be released. Look at all of those things manually, and then you can kind of make your own decisions. Just because that kind of automated setup hasn't been done yet doesn't mean you should avoid the project or not look into it yourself.
How many of you care about metrics? How many of you use OpenTelemetry? Nice, right? So here's a great tool to use. It's one of the most popular tools to use, and I think observability is really like getting its day in the sun. People are realizing
was like every conversation last year. I feel like
that you have to track where you're going, right? Just because it's open source doesn't mean you just let it go. and like you don't need to see like who's adopting, who's this, who's that. It can be all anonymized, but you still want to know what's going on with your users. So again, like you look at what's going on in Clo Monitor and you can see all this good stuff. It's got an 82 though, right? But what does that mean? It means it's losing on best practices in security. So you can scroll down to the best practices and security. Just don't get nauseous with all my scrolling. Well, that doesn't make sense.
Huh.
Interesting.
We found a bug.
Sweet.
You know what? This is a great opportunity for us to go later today and report this in some issue queue somewhere.
That's Catherine's job, not mine. Okay. So next up.
Or any of you could do the same.
Crossplane. I mean, we've got all these projects that we're going through. Like, does anybody want us to pick a project that they're interested in and we can go through it in the landscape? Is there something anyone has been like looking at that you want to evaluate?
We can evaluate it together. Anyone? Favorite?
Okay, cool.
Okay.
I'll take that feedback.
Thank you.
Yours the only one that matters. Thank you. All right, so Crossplane. Anybody use Crossplane? Does anybody know what Crossplane is? Yes? I wish I have extra hat. That was good. That was good.
I didn't even hear. We need to repeat it for the recording. What did we say? Hold on. You know what?
Go get
I'm
it.
going to take you, and then we're going to repeat the funny so that everyone benefits. You got to say it on the record.
According to the slide, it's a cloud-native control plane, but I believe it's a single pane of glass that lets you control different environments across different, is it clouds or clusters or wherever your compute is running?
Yeah, it's highly configurable. You can make it make the most sense for you. And they have the coolest little icon, which is a popsicle. So let's dig in. So Crossplane, like we said, it's a cloud-native control plane framework that allows you to build control planes without needing to write code, which I think is, how many of you write code every day? How many of you don't write code every day? Right, so how many of you want to use a tool where you don't have to write code, you can just kind of drag and drop and make it happen? There we go. So control plane.
Recovering engineer.
So as we scroll down, we can see that it's got almost 10,000 stars on GitHub. Again, 267 contributors. I think that's the most important part here. The last release was in February of this year. As we scroll down to the Clo Monitor, they have an 87. And where are they losing out on? Again, best practices in security. So who in this room is interested in security? Okay. Security is a big deal, right? And as you can see, some of these projects are really lacking that piece of the puzzle. So if you're looking to contribute or you're looking to do a little bit more, this is a good opportunity for you. Do you have a question?
So how often are these metrics that Cloud Monitor measures against, how often are they updated? Who decides what security means for
that is a good
CNCF
question,
project? And
we will get back to you on that. I don't know, but we need to talk with the, okay, I don't know what I just clicked on, but there's some dev stats for Crossplane. Let me get back to you guys, and I'll post it on LinkedIn. I'll just do a little posting, or you can just follow me, and yeah. But I don't know, and that's something that's really important.
It's definitely automated, and so I would say frequent is a safe bet. But how exactly frequent, I don't know.
I wish George was here.
What does security mean to CNCF?
Oh.
So like I said, so if you go through the CNCF sort of GitHub repo and there's a security section. So there's lots of things that people have to check off. And so here, when we just look at what Clo Monitor is looking at, just to stay focused, security, right? So they're looking at the binaries, a code review, their dependency policy.
This is, I'm pretty sure, OpenSSF scorecard checks.
Do you think this is OpenSSF scorecard?
Yeah. Signed releases, again, they're not signing the releases, so there's an attestation question there. token permissions, that's an interesting one. That's kind of low-hanging fruit. I'm surprised that one's, see, there's always an opportunity. Someone could go in there and help them fix that.
Yeah. So, but we will figure out the other piece.
SBOM, also pretty low-hanging fruit.
It's interesting, right? Like, you're like, how's that? But again, when we think about open source and projects, we're all dependent on volunteers, or, you know, maybe your company pays for you to work on an open source project, but you only have a certain percentage of your time. So there's always opportunity to do more.
There are never enough people working on security.
Okay, so Pixie is another
Always
one
need more.
that is sandbox, and it's instant Kubernetes native application for observability, another observability tool. So if you're, again, interested in metrics, maybe you want to try Pixie out in addition to OpenTelemetry, and then you can, what did I do?
Nothing, just the icon.
I told you the icons were bad. This is what happens when you use AI.
Ready?
Not me, this one. I just put
I'm
in
not
links.
good at graphic design.
Okay, so Pixie has a score of 97, and it's an incubating or a sandbox project. So this might be something, if you're interested in metrics, that you might want to build on top of and use. So it's got all the license checks, it's got best practices, it's got its security, so it's missing a dependency policy and some security insights. But what I'm trying to say is, like, just because OpenTelemetry is a project you all know about doesn't mean it's the end all be all. Like, open source on top of open source, project on top of project. Maybe OpenTelemetry and Pixie give you a better worldview of what you're looking at. Maybe you're like, OpenTelemetry is great, but Pixie has the one thing that I really need. So don't be afraid to look at things and to try them and see if it works better for your organization.
Something cool about Pixie also is that it uses eBPF. Anybody know what eBPF is? Excellent. We're talking about like kernel level observability. More observability. See, it's the cool thing. Sorry, question. I'll come over there.
Getting your steps in, girl. Yeah. Oh yeah, the Santa. I told her. I said there's like a weird looking Santa in this, and it's not even a Santa. It's like a troll.
Hello. I had a question about the scoring for sandbox and incubating projects. Is the score like carried over when the project is moved forward, or is that score specifically for that tier? So Pixie has a 97, and it's missing a couple things. So for your project to get graduated, does that mean that you need to get 100 within that tier to move on and then get rescored, or?
Okay,
I
so
don't think so.
that is a good question. So you don't just move, right? You have to apply to move. And so when you look at,
As I understand it, the
Ugh.
score is not so much
terrible.
directly correlating with the status of the maturity level of the project. It's an indicator that's a little bit more independent from the project status. Oh, another question. I'll come get you.
So it may vary, but I'm curious what different kind of people's motivations are to donating a project to the CNCF.
Okay.
From companies and whatnot.
so motivation. So
Fabulous.
when I was at my former company, we had a project that we were trying to get off the ground. And we knew that we couldn't do it on our own, that we could only get it so far. And we needed to get other stakeholders. We needed other big companies to be a part of the project that worked in different areas that we weren't experts in to make it move. And so we realized the best bet and the best way to get in front of all of these companies that had said, like, yeah, we want to help you, but nobody was actually doing anything, was to then say, okay, well, if we donate this, or if we try and donate this to a foundation, will that spur you to more participation? And they said yes. Because companies that are part of foundations are paying money to be a part of those foundations, but they're also paying their developers to work on the tools that are at those foundations to help them move faster. So one of the reasons to do it is to get more use, more adopters, more innovation. Another is to just get help. Maybe it's a cool project that you and your buddy created, but you just don't have the time and you need the support of a foundation. And what does a foundation give you for support? They give you marketing support, they give you legal support, they give you infrastructure, they give you a platform for communicating via either Slack or Zoom meetings, Google Calendar, all that, Google Meet, all that kind of stuff. So when you are trying to get out of the bootstrap phase, donating to a foundation can really be a way to get you more visibility, more of the things that you need, and that is super important. But again, it's a marathon, it's not a sprint. There's 200 plus projects at the CNCF, right? And as you can see, the ones that we've gone through, like, can get lost in the shuffle. So donating and getting accepted is step one. Step two is then how are you marketing yourself to get more recognition? Are you trying to do open source on top of open source? So if you're Pixie, are you talking to the people at Helm to say, hey, we're gonna like work with some observability stuff and like get you guys more information on what you're doing, like let's cross promote, let's like do that kind of stuff. And I come at everything from a marketing background that just, I'm a marketer that ended up in tech. And what I see is that we all get very siloed, right? We're all trying to do the work on our own project and we don't realize that we're not talking to anybody about our project. And that's where the foundations can help, like really using them as a resource to spread the word about what you're doing, how cool it is, and all of that kind of stuff. And so if you are going to KubeCon, either North America or Europe, I highly recommend you go to the project pavilion because then you'll meet all of those projects that need the help, that are looking for things, that are innovating that you might not know about. And it's a really good opportunity for them to get more exposure, but also for you to get the exposure as well.
I would also add, I think, again, motivations for donating a project. No matter how big the company and how many resources you have, donating is a signal of vendor neutrality. If you want that kind of community adoption and community support, it really does need to be under a vendor neutral umbrella like the Linux Foundation. And again, no matter the size, we all benefit from working together with our collaborators and partners and our competitors, because if you collaborate on the common tasks, it becomes more efficient for everybody. And the software that we create becomes more valuable, and it becomes the best solution because you have all of these different people in the room.
I mean, you would be surprised at the number of banks that are CNCF, LF, OpenSSF, name it, Eclipse Foundation, OWASP. They're all, because banks have to innovate, right? We're talking payments, we're talking money, we're talking all this stuff. And they're using what is happening in the open source world and then building proprietary stuff on top of that, right? So again, but someone talked about stages. So if you go to the CNCF's GitHub repo and you go to the TOC, which is the
Technical Oversight Committee.
Technical Oversight Committee, and you go to processes, you can click down and see how to apply for different levels. And you'll go and you'll see all the different like forms. They interview adopters. They make sure that you're not just saying that we have 2 adopters. No, they're going to go to those companies and see, how are you using this? What are you doing? And then, again, it's an application process. Just because you apply doesn't mean that the TOC is going to grant you the next level. So the governance of a project is also something to think about. Like, do you want the freedom to run the project the way you want to run it, or do you want to be beholden to the CNCF guidelines of what a governance model is? There's multiple governance models, but you decide when you donate, like, what you're going to do. And I think, like, it's 10:46.
Do we want to just, we want to kind of blow through the...
Yeah, I mean...
Yeah.
So I think what we're trying to really get out of this is like, be a part of the foundation. Your company doesn't have to be a member for you to be a part of the foundation, but if they are a member, ask them about the benefits, because there's like, for Percona, we're silver members, so we get 10 training credits a year. And if you want to get like Kubernetes certified, it's, I think for the training and the test, it's like $700, $800. But guess what? We pay into the organization, and now that training is free. So sometimes marketing people don't realize developers want training and want to do all this stuff, so don't lose that opportunity. At the CNCF, there's also a job board. The Slack channel is super popular, so you have projects listed in the Slack channel, but you can also ask questions in general or whatever, and somebody is going to answer you. I like to say, like, network at your own comfortable level. So if you're like, you like to kind of just creep on things, join the Slack, just kind of creep on the community, see what's going on. You can join the mailing list where you don't have to participate at all, just get the like rundown of what's going on. The calendar is, like, I think the most unused feature of the benefits of the CNCF, because that's where you see all of the meetings. Like that's where you see like the links to the meetings, the who's having what, who's talking about what, and then you can determine like again, do you want to sit in on a meeting, find out more, or maybe you have something to pitch.
And don't be shy about it, right?
Yeah.
It took me, I have to admit, it took me a long time before I worked up the courage to go to a community meeting like that, because I go, well, what do I have, what do I have to offer? These are experts, right? I think everybody kind of goes into open source projects and open source contribution with a little bit of that imposter syndrome, but do not be shy. Everybody's very nice, and they would love to see you.
Yeah.
I would also like to mention the Slack channel has a channel dedicated to podcasts, where the people will share podcast episodes that are about cloud native projects and topics of interest. It's actually really great if you're into podcasts. Anyway. Thing. I occasionally share mine there, but I forget. But yeah, anyway.
Any questions?
Do you want to show them the cool thing where you can download? Where we remember?
Oh,
we learned about a feature.
Yeah. This was like we were astounded.
Like in the fall, super helpful if you are trying to kind of organize your evaluation.
Yeah. So say
process.
You filter by we don't archive graduated that are observability. Blah, 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 and you hit apply. Where'd it go? Oh, there it is. You can download. You can
items and projects.csv. You can download this stuff as a spreadsheet. It's pretty great.
Yep.
I didn't know that until November of this past year.
And then you can
Been around a while, still never noticed it.
So then you can kind of see all this stuff, like where you can just go at it at your own leisure, right? Where's Sandbox, who's incubating, when was the last time there was when did they get sandboxed, when did they get incubated, when did they graduate, when did they have their last security audit? So you can sort it however you want. You can go crazy with your Excel. But it's a nice feature that we were
I thought it was a pretty neat trick.
Blown away by.
I like to remember to share it wherever we can.
So yeah, so it's just this little guy right there, little download. But if there are no questions.
Any questions? Any more questions?
So absolutely would love for you guys to connect with us on whatever channel is your favorite channel. We do still have X, but we kind of, not a big fan of especially what's going on now. But that takes you to Catherine's GitHub, where she's got all of her podcast episodes and all kinds of cool stuff. That's my LinkedIn. I'm hiring currently if anybody is looking to get a job in event management. Just throwing that out there. Percona's also hiring for a couple other positions. Go to our career page.
Intel's probably hiring for something. Let me know if you see anything.
Yeah. And with that, then we're good. Thank you so much for coming.
Thank you.
Josh will be coming up in just a minute. He had a back-to-back session, so he had to go to the restroom.
Testing, testing. That sounds pretty good, yeah? Okay.
Test, test, test. Test. They were. Thank you. This is the blow. That one has already been working, so it should still be working. This one not tested.
Okay, this is still working? Yay. Okay. Well,
Welcome to the Cloud Native track, track B at the SCaLE conference in 2025. You're in the talk covering Podman for development, deployment, and test. And we're honored today to have Josh Burkus as our speaker. He's a longtime and very active coordinator of SCaLE in general and the Cloud Native track in particular. He works on containers and Kubernetes for Red Hat. And you may know him formerly at SCaLE as being very active in the Postgres community. Take it away, Josh.
Okay. Thank you very much. Welcome, everybody. We're going to talk a little bit about Kubernetes application development. So basically, this talk is for people who are developing containerized applications in Kubernetes, including personal projects and that sort of thing, that you work on your laptop, you know, that you actually work on development on your laptop, or that's what you want to do, and you're hearing this talk to see a way to do it. If that's not you, right, if you are in a big enterprise environment where you have to do everything through the corporate CI/CD and that sort of thing, hopefully you'll get something out of this for your own personal projects. What I am not going to be talking about here is, I'm not going to be comparing this with any of the tools from Docker, the company, because quite frankly, I haven't used any of them in 6 or 7 years, and any comparison I made would not be fair. I'm not going to be talking about big enterprise production CI/CD stuff. If that's what you're into, we have other talks about Argo and Flux in the schedule, which will give you that set of tooling. And you're going to see me doing a lot of Podman and kube control on the command line, but I'm not going to go in detail about how that works, because I want to actually show you the desktop tools and spend a little bit more time on that. One of the other things I want to say here is I'm doing this whole talk and all of the demos on my Project Bluefin laptop, which is right here. I can't hold it up because of the cables, but it's a framework AMD Ryzen laptop. It's running the Bluefin DX spin. Bluefin is what we call an atomic distribution of Linux, where it's been designed to be a shippable image for the whole system. The DX branch is for people who do software development. And as a result, most of the tools that I'm going to show you already ship with the OS image. It makes it really easy to actually do the kind of development that I do for Kubernetes and that sort of thing. And if you want to know more about that, you can talk to George Castro out in the hallway, who's one of the leads of the project. But let me talk to you a little bit about a project called Electo. Electo is election software. We developed it a couple of years back for the CNCF, primarily for Kubernetes, for the Kubernetes Steering Committee elections. It's actually now used by a number of other CNCF projects, plus a couple of projects that are not CNCF. It's a GitOps-powered election system so you can do online, secure secret ballot elections. Currently, the only maintainer in the project is me. Now, I've been doing, work on Electo. I've got this long list of tickets and feature requests that people want that I get to when I can get around to it. The Electo software is not a very complicated application, rather deliberately, because I didn't want to have a lot to maintain. What's going on with the sound? Okay. I'm getting some echo back. But if you can't hear it, then that's great. It's a rather simple architecture. We have a Flask application. And the Flask application talks to your choice of relational database. Users interact with it via a web client. And it ties into OAuth for authentication and a repo on GitHub or GitLab in order to hold the GitOps configuration data. And so when I'm actually working on Electo, I need to build and test basically the sort of core, right? Is what we're actually, the application is just the Flask application, the stuff that I need to test, but it doesn't work without the attached database, and so I need to actually do that, spin it up in the attached database. So for a long time, what I've been doing here is, I've got a Docker file in the main repo, and use that to build containers. It's also the base for the Docker file for the people actually installing it in production. And then I, have been spinning stuff up on command line with Podman to do some basic testing and that sort of thing and trying it out. But a great thing happened that forced me to change my workflow relatively recently, which is Sam joined the project in order to build out our automated testing, which is needed to happen for a long time, since early on in the project. But having Sam do this means that we need to have a way to stand up a test copy of the application that's a little bit less ad hoc. And because I work at Red Hat, because I know the Podman desktop team, my thought was, okay, well, this is a good use for Podman desktop. Now, for those of you who haven't seen it before, how many people have seen Podman desktop before here? Okay, so about half, well, a third. For those of you who haven't seen it before, what it is, what the goal of the project is to have a comprehensive desktop user interface, set of tooling for working with containers and pods and building Kubernetes applications, right? It is very much in development, which you'll see some of it later on, but it already has a whole ton of features that make it a useful development tool. It supports both Podman and Docker, making the name of the project a little deceptive because you don't actually have to use it with Podman. You could use it with Docker, also with Lima. It's ported for Linux, Windows, and Mac desktop environments. I will be doing all my demos on Linux. Your workflow will be a little different if you're in Mac or Windows, because those involve running a virtual machine to support all the container stuff, whereas I have that natively. But it all works. And they built an extension plugin library on it to allow you to plug in additional components that you need to work with. Like if you're deploying to OpenShift or to Lima, or you need to work with AI models, right? So now what this is going to let me do is to actually have a sort of UI-powered workflow to start out with the test containers that that I originally had and originally worked with, to convert those into a pod, and then to take that pod and push it into a Kubernetes server in order to actually build it out as a testable Kubernetes application. So let's go ahead and do that. Let's first look a little bit. So one of the first things, so I told you we need to do a lot of testing, right? So one of the first things I need to do here is, right now the release version, current release version of it, which is 0.8, I think, is based on Python 3.11 Bookworm. Anybody here who's a Python geek will realize that that is not the current version. So we need to stay current, we need to stay secure, which means that I actually want to do it on 3.13, which is the current release version. 3.14 is still an alpha. But if I'm upgrading the Python version, that means I need to test. So let's start out first. Our first thing that we need to do here is, so here's the Podman desktop UI. So we've got a whole bunch of stuff. You can see here, we've got containers, pods, images, volumes, Kubernetes, the extension manager, and then we actually have a couple of extensions in here for bootable containers and create. We'll get to those later. But right now we're going to container images because what's the first thing we need to do if we've made a change to the code and we're going to test it in containerized environment? What is the first thing we need to do, right? Build an image, right? So obviously I can do this in the command line with Podman, but I can also point and click it. So, and let's go to home, get CNCF, Electo, and then we've got a Docker file right there, yeah? And the image name is going to be now, like with Docker and Podman and the command line, the image name also kind of determines whether or not you're targeting it at a particular repository. If I was going to continue this to pushing it to a public repository, I would not have named it localhost, but I'm not going to do that over conference Wi-Fi. So it is going to stay on localhost. One of the other things you can do also, with Podman Desktop, which you'd have to do a very different way, is choose your target for how you're actually building this. I actually have three choices here. I've got Podman, I've got Docker, and then I'm also running a Podman virtual machine, which is installed for boot C support. Again, we'll get to that later. But right now, I just want to build it via Podman. And I don't need any special build arguments, and we are targeting x86. We do actually have some cross-compile support in here. So let's go ahead and build that. And it will tell us how it goes. It should be relatively quick because I'm supposed to have all this stuff cached. So there we go. And we will get our image pretty soon. And so all of the most of the commands, not all of the commands, most of the commands you do with Podman Desktop, it's going to default to giving you the telemetry and the output, right? So you can see what's going on. First of all, so you know how long it's taking, and second, so if something blows up, you immediately know what it was that blew up. Yeah, there's a bunch of dependencies. Python, we were doing adding a new version of the ballot testing, and I'm like, wait a minute, how did we get pandas in here? Because pandas, of course, drags in all of SciPy, yeah? Which what? What editor are you using? Okay. We can actually cut over that. The editor right over here is Zed. So a while back, a bunch of folks at GitHub built this editor called Atom that was supposed to integrate well with working off of GitHub repos. And I got to like Atom, and I never switched to Visual Studio. And now the same people who are no longer working in GitHub actually release this editor called Zed. And since for desktop editors, Actually, for a long time, I was a KDE user and really liked the old KDE text editor setup, which was designed to kind of mirror an Emacs split screen setup. And this is still that kind of look and feel. Plus, it also has really good font rendering, which I really appreciate. Yeah? Yeah, actually, if you scroll back up, let's see, does it show the build command? No, it doesn't show the build command. There's a lot of other stuff where it's easy to get the command line equivalent because, like, for example, anything that's producing YAML, you can extract the YAML from it. I'm not sure whether or not we can get the build command from building an image. You can get that out of the logs. So,
like some tweaking for like parameters and stuff that specialize, not just the out of the box.
Yeah, we need tweaking for parameters and that sort of thing. Yeah, I mean, and that's actually part of it. I can't go back to the interface without canceling the build. But in the interface, you've actually got a section where you can say, okay, I want to add these other parameters. Because, yeah, that comes up, like, clearly, right? And I just realized that I did actually make a mistake with setting this up because this was supposed to be pulling from my local Python module cache, and I don't think it is. I think it's pulling from the internet, which is why it's taking a while. But it'll be done in a minute. Well, while that's building, I will actually do the next step because I said, right, we need I do have this cached if necessary, but one of the other things that we're actually going to do, because we actually need two containers, right? We need a database container, we need an application container and a database container, minimum two containers, right? And the database container I'm going to spin up is actually a Postgres container because I'm a longtime Postgres guy. Oh, right, and of course I'm hammering the internet, so this is going to take a minute. Oh, good. It's proceeding. So we're going to get that from, oh, actually, I want the README here. Okay, well, I guess this works. We're going to actually pull a Postgres image, which has quite a bit of configurability, which we're going to care about in just a minute. But it's exactly how many requirements you have in here. So, okay. I am going to, let's see, can we actually, I'm going to go to containers here because I already pulled the Postgres image. So we will let that keep running. The problem is that I lose my ability, this is one of the things I lose my ability to get back to the build screen. So hopefully it'll finish up. We will leave that running. And in the meantime, I will start up my Postgres image. So this is the list of all of the images that I have on my system. Yeah?
How gracefully can you cancel out of what is running now?
There was actually a close button on there that would have canceled out of it, but I did not actually want to cancel out of it. I wanted to keep running in the background. Yeah.
Yeah, of course you want it to run, but if you were to cancel, does it clean things up?
it doesn't deliberately erase anything that you've downloaded. I mean, those layers stick around. And that's true in general. It'd be true if you did it on the command line too and canceled out. So, let's go ahead and I'm going to go ahead and actually start the Postgres container to actually show you before we start. So, this is the Postgres image, and we have this little play button, which actually means to run the image. But that's not going to immediately start a thing because you often need to set some parameters, right? So we're going to have 5432. We need to expose that port. Although actually that is a lower port, so we'll expose that as a higher port. And we also need to set some environment variables because, like I mentioned, nope, wrong way. The Postgres official image is built with some configurability, and there's a bunch of environment variables, some of which you are required to set, and other ones of which we want to set. So, oh. And then add another one. Oh, that is not the right spelling. And we will not get a usable. So we are creating a user electo, database electo, password electo for that database. And there we go. And that is up and running, because if you already have the image cached, then we will have some containers, right? And we have our Postgres database running. So let's say we've actually finished building 3.5. Okay. I don't know what's going on with that. I'll tell you, I cheated. Version test 3.4 is actually also the version also has Python 3.13. So I'm going to go ahead and just fire that one up. Yeah? Yes, it is. Yes, it is. I'd actually have to look at Podman secrets. I'm used to Kubernetes secrets, so I would actually have to look that up. So we are going to go ahead. What is going on? Okay, we're going to go ahead and start from this image. And so you saw my actually setting here. So first of all, we want some custom port mapping. And I'm actually mapping port 9090 to port 5000. Port 5000 is the default port for you WSGI apps. And we're mapping port 9090 to it for reasons that will become obvious later. But there's also a second way to load a bunch of parameters in your container, and that is to use an actual environment file, of which we have a bunch. And we're going to start out with the testing environment, and this is for running our unit tests. So it has a whole bunch there designed to go ahead and run the unit tests. Oop, what did that not like? Okay. But we'll see. Oh. Right. Okay, let's try a different set of parameters. Okay, and actually what I'm going to do here, the other thing you can do here is you can do what you could do in the command line, which is to do things like override the entry point. So rather than running the default program, you're going to run something else. In this case, I'm going to get myself a command line on there. I've actually forgotten which environment file I want for the first stage of this, so let me double check. Here's the environment files. And actually particularly, I wanted to actually double check. Oh, okay, so I do want AMP testing for the first one to run the unit tests. So I'm going to change the environment file there. And now we're going to start. And here we go, there's no log because all it did was start up bash. So make this a little bit bigger. Fortunately, the test size is not that configurable in this terminal window. It's fine when you're actually using the desktop, not great, so great for display. But and I'm going to go ahead and run my unit tests, and the unit test passed. However, for those of you who are in the front and can read that, you will see that actually only 7 tests passed. We do not have a complete suite of unit tests yet. So we do a bunch of ad hoc testing by actually running the application. So let's actually go back to our list of containers. We want to go ahead and stop that container, right? We're going to stop it. Okay. And actually, I'm going to get rid of it so we're not confused by it in the future. And let's restart the container with a different set of parameters so it can actually connect to the database and we can actually try it out. So, I'm going to take test, oh, hey, here, test 35, finished building. Yay. It just shows up. So let's go ahead and run that one. Oh, and here. And we're going to use the regular entry point, where again you're going to get the custom port mapping. And we're going to bring up a slightly different environment file because I want this to connect to the local database. And this says to connect to the local database. However, I need to do something else first. So I'm actually going to go back to the containers because I actually need to modify that environment file because we have the local database running here, right? And we need to know where it's running on the container network. And that is where this inspect tab comes in. So this inspect tab does a dump of all of the information that you can get out of the Podman API or the Docker API if you're using Docker about actually where that's running. Now, I could route it through the host, but that can be weird sometimes. And so I just try to go ahead and use the container network, which means I need to know what address it has. And there is that address there. So 1088.02. And then I'm going to go ahead and stick that address into my setup file. Now, it actually hasn't changed from the last time I ran this test, but I would stick it in there, right, so that my new test container can actually connect using the container network instead of trying to hop out to the host network and come back, which, like I said, again, can be weird and sometimes doesn't work. So let's go ahead and start up version 3.5. Okay, again, give it a name. Custom port mapping. And this is why I had to remember to stop the other one, because if I tried to claim the same port, it would blow up. Well, it wouldn't blow up, it would just refuse to launch. And we're going to choose our end file, and we're going to go ahead and run it. And there we go. The app is running. It's telling me it went through the whole business of connecting to the database, connecting to GitHub, syncing everything, and it is ready to go. Well, how do we take a look at it? Well, that is not. We need to actually, so I did. This is how, so here's the app. Let's test that we can sign in. Currently, this is actually doing a hack with a redirect to GitHub OAuth, which is why we get that missing or invalid CSRF token. Because it's still OAuthing against actual GitHub. But here where I logged in, I can look at the various dummy elections that we've had, et cetera, select the name of the election, everything else, right? So, up and running as my local 2 container thing, right? But I said, hey, the whole reason I was using Podman Desktop in the first place was I didn't want to stick to doing this as 2 ad hoc containers, because that's not good for handing it over to Sam to actually run himself, to run his own tests, right? So, by the way, you can get huge amounts of log output if you want to. So that means that we need to take some steps, right? The next step is, one of the ways that Podman is different from Docker is that Podman allows you to run things in pods, like Kubernetes pods. And a pod is its own world in which the containers running in it share resources. And among other things, that gets us out of doing stuff like, hey, I need to go look up the IP address for the database container I just started, right? Because you don't have to do that, because they can just share network. So, let us go ahead and shut these down. Actually, I didn't really need to click that. So we're going to shut down those 2 containers. Okay, and then once we have shut them down, and actually, I'm going to make a small change though, because I said we're going to be using the local network to connect to Postgres instead of using the container network. And that means that I actually need to make a small change to configuration. So we're going to actually run another instance of 035. So again, we'll call this electopod. Oh, actually, we don't, yeah. And we're going to connect a different environment file, which I'll show you in a minute. And this is the demo pod. And we're going to go ahead and start it up. Now that's going to give me a whole bunch of errors because it can't actually connect to the database. Because I've shut down the database, which it's telling me. Can't connect to the database, can't do any database sync. Great. Know that, was expecting that. Didn't matter because I'm about to restart the container. But let me show you, by the way, so the change in configuration files here is we're now connecting to the database on localhost. So, now the way that you actually start a local pod in Podman, or the easy way to do it is, let's take the electopod container and the database container, and see this now here? We have create pod. Great. We're going to create pod. These are the 2 containers we're going to be running in the pod. And the thing is, we don't need to expose the database ports anymore, because only the Electo app needs to talk to the database. We don't need to be able to talk to the database, just the app. So we're not exposing those anymore outside the pod. All we need is 9090 from there. And so we're going to go ahead and create the pod. And there we go. And if you actually look at the pod, it tells me here's what's running in the pod. And we've got 3 containers, our database container, the Electo container, and an infrastructure container that actually handles network routing and a couple of other things. And given that, let's go back to the Electo app, right? See what we got here. And because this is a new instance of the Electo app, it wants me to log in again. And again, we're doing that GitHub redirect, so it's going to give me that dummy token error. But it works. We have our elections. I could test the various functionality ad hoc of Electo. But that's still not where we wanted to get, right? Because this is still a local pod running under Podman, which is great. It allows us to test some other configurations, that sort of thing. But it doesn't let me get to doing what I want for a complete install. We really want to run this on Kubernetes, right? And we want to be able to maybe even run it on a production Kubernetes. Well, this is stuff that Podman Desktop can help us with. So the first thing that we actually want to do here is because I don't want to oversubscribe the port, we're going to shut down everything in this. Well, actually, I don't think we need to shut down everything in the pod. I think we can actually go ahead and do this. Okay, there we go. Okay, why are we not getting, oh, right, because I need to be running a Kubernetes. Actually, I do need to stop the pod. Well, I don't know that I do. Hold on. Well, we'll see if we need to. Okay, so I'm going to, for the sake of this demo, and actually, this is how I test things initially. I'm running in a local Kubernetes. Because I'm running this on a Linux laptop, my easiest route there is a utility called kind that was actually developed for testing Kubernetes itself. It's nested, it's running Kubernetes in nested containers. So you have a container that has multiple containers inside it that have the Kubernetes components. And this is actually how some of TestGrid works for Kubernetes, which is what it was invented for. And we have support for this. So now, I'm not going to go through activating kind. So the way you actually activate kind within Podman Desktop is we have the kind plugin, which ships with Podman Desktop right here. And so you can actually go into the kind extension. And if I didn't already have kind running, there would be a button for me to tell it to actually create a kind cluster. But since it's already created a cluster, it's not offering me that button again. So when you actually start it up, initially it downloads some things, which is why I pre-created it. So we are going to go ahead and start that up. Okay, where are we? Stopped. Oh, I was afraid of that. Is that running now? Yeah, I bet that, yeah, that's the port conflict. Oops. Okay, so I'm going to need to stop all the containers in this pod. So, Okay, and now restart this. Sorry, I tried to run 2 different things on port 9090, which it did not appreciate. So, you know it happens. And you get to see a little debugging in the meantime. Okay, so now I have kind cluster running, right? And if I actually go to pods, one of the things I can do here is the action is I can say, deploy to Kubernetes, right? So that's going to be our option, deploy to Kubernetes. Now, what does that mean, deploy to Kubernetes? Well, at any given time, you can have Podman Desktop connected to one Kubernetes instance. And that Kubernetes instance could be a variety of things, right? It could be kind or Minikube on your local system. It could be a remote OpenShift, or I think we have GKE support cluster. It could be other sources. There's like a whole set of plugins for this sort of thing. And so whichever one you've told Podman Desktop to be active, that's going to be your current Kubernetes when you say anything like deploy to Kubernetes. And when you actually look at this dashboard for Kubernetes, that's the one it's going to connect to, right? So because we're running a kind thing, we only have one node, right? Everything's on the single node. We have no pods, no deployments. We have one service, this is the service running the Kubernetes proxy for kubectl, kubectl. And that's pretty much it. So we want to go ahead and actually push this pod to it. But we have to do something else first. Because we're running this locally, and because I used a local image, which is something you'll do a lot when you're actually hacking in development, right? Which is, this image is on the main host of my laptop. It is not inside the kind container. And because it is not a publicly addressable image, if I try to start it up now, it's just going to fail. Which I would show you, except it takes a while to fail. So instead, what I'm going to do here is I'm going to tell it to push the image to the kind cluster, which will take just a minute. And I will say, by the way, we have a team, there's a whole team of Red Hat people plus community members who are actively working on Podman Desktop all the time. I actually found a bug in this push image functionality, and I had good timing, and they incorporated the fix into version 117, which was released on Monday. So that is, there's a triple dot for a lot of items, and this triple dot is contextual, right? Because it wouldn't offer me push to client cluster if I didn't have a client cluster running. So now that we've actually pushed the image, we can push the whole pod. So we're going to say deploy to Kubernetes. And this is actually going to give me a preview of all of the YAML that it's going to be pushing. Replace host port with services, which is something we want to do. We want to create an ingress because this is a web application, right? Currently, for local Kubernetes, Podman uses Contour. And you could also lock it down if you wanted to, which is something you do for production but not for testing, right? So let's go ahead and deploy. And that'll take a minute because it's got to generate this and create all of the objects. Although actually, I think it's done. It's very fast. Yep. We have our pod here now. The pod only has 2 containers because since it is no longer running in a local pod, the infra is located in kind, not inside the pod. So you can see here, we got this, inspect. We can get a terminal for the 2 different ones. And of course, the important question is, can we actually interactively test the application out? And here we go. We've got the application up and running. Now running on a kind cluster. And we can try it out. So now we're actually making progress. I can actually do some other things, right? So first thing is, let's stop using this insane 2 sort of to container configuration. Because like one of the things you notice I'm doing all the time is I'm loading these env files in when I start up the container, right? That's not really how you would do it when deploying to a Kubernetes cluster, right? When you're deploying to a Kubernetes cluster, what you're going to want to do is you're going to want to create a config map. Or actually a config map and a secret with different values in it, right? So the way that we would actually do that is new plugin create, which is it's an optional extension, and I can tell it to create a config map and give it a name, which is going to be and then I'm going to take the env demo pod right here, and I am going to actually stop there because when I was retesting the site yesterday, I found that there was a problem between this new version of the create plugin and what turns out to be a very old version of kubeconfig that I have installed on the system that I need to upgrade, and I ran out of time to upgrade. So this will actually blow up if I hit the button. But you get the idea, and then sort of our next steps here, right, are going to be create config map and secret, create, for that matter, create a fake OAuth service, so we stop doing the weird localhost rerouting for GitHub, and thus, it actually behaves reasonably when we're doing auth tests, etc. So, it's a little demo. There's some other stuff for any of you. How many people here use Docker Compose? Okay, if you use Docker Compose, like I said, I have not used the Docker tools in 6 or 7 years. Docker Compose is not, whereas I have been writing Kubernetes YAML for 6 or 7 years. If you're used to Docker Compose, then Podman Desktop actually supports Docker Compose in 2 different ways. If you have Docker Compose itself installed on your system, it can access that and use Docker Compose to build Kubernetes YAML and actually load stuff in your target Kubernetes. If you do not have Docker Compose installed in your system, it can use a different tool called Podman Compose. Podman Compose does not have coverage for 100% of Docker Compose's functionality, so if you can do it via Docker Compose, you should do it that way. So we built a container image, we did basic container tests, we converted to pod, we exported the pod to Kubernetes, we started looking at building out the Kubernetes infra. Now what's going to be next for me in terms of my electro testing and everything else is to create a fake auth provider, create a persistent volume setup that would be similar to what we use in production, and then build another container that actually runs automated web tests so that we can actually have full testing for all of the UI. So, one of the things I actually promised, do we have time here? Is to show you a little bit about bootc support, because I realized I put that actually into the talk description. It's not really in the workflow. I don't need bootc for Electo itself, but this is something we recently added, and it's kind of fun. How many people here know what bootc is? Ooh, nobody. Okay. So here's the basic idea of bootc is you build a container. Now, a standard application container has user space in it, but no kernel. But it turns out that if you build a container, which is, after all, just a tarball with metadata, and you stick a kernel in there, and you have a special bootloader, you can actually make an OS image and build it with the same container tools that you would build an application image with. And since container tools are actually fairly advanced and sophisticated and reasonably user-friendly, and boot image building tools are definitely not, the bootc project folks actually created this whole set of tooling to do it. And to make it super easy, we've actually added some interfaces to Podman Desktop. And so you activate the bootc plugin for Podman Desktop, and what you can do is start by downloading any publicly available images, like other kinds of container images. you can use a file formatted like a Docker file for building your application image, only you now can add other stuff to it. Like you can add kernel commands if you want to load kernel mods, you know, a bunch of other things. And the difference is that you're going to be pulling images that were built with a kernel. But those images go in container registries like regular application containers if the container registry supports it. Docker Hub currently does not, but Quay and Harbor and GCR, I think, all support OS images because they support arbitrary extensions, which is the support you need. And you know, and then you can do whatever sort of modifications you want and go ahead and build it. I am not going to do that live in front of you because the other thing about OS images is because it has a kernel in it, it's like, I don't know, 1/3 of a gigabyte in size. That is not good on Conference Network. So not going to do that. So instead, we have here, we have one bootc image that we've downloaded, which you can actually see by looking at the container images right here. So that's that image right there. What does inspect look like for one of these images? That's actually kind of fun. It's got a whole bunch of other information in it. It has a lot of layers because OS image. And then one of the other things that you can actually do from the bootc, so the bootc image is the canonical tarball. But you want to actually load this on a system, often what you need to do is you need to export it into one of the 7 or 8 different formats that we use for shipping OS images, like QCOW or RAW or VMware or other things. And the bootc extension supports building it to 8 different target types, which you can do right here. So you can use it to build your images and then use that to, for example, the main thing, biggest use for bootc is shipping it to a device where you're basically going to have the device one app which is built into the OS image. So, ta-da. Hopefully that gives you enough to try Podman Desktop for your own project. It's easy to go from tinkering to production. You saw all my targeting Kubernetes as my local kind instance, but that doesn't have to be local kind, right? It can be your OpenShift or GKE or self-build Kubernetes, you know, in the cloud, et cetera, that you're actually running production on. It's a really helpful when you're maintaining small applications as one person, right? Argo and that sort of thing is awesome if you have to actually integrate work from an entire team of 20 people, but if it's just you, not so much. And it's also a helpful way for you to learn Podman and Kubernetes without spending a whole ton of time learning command line switches. So I'm going to put up all the information, resources, and contact there, and let's take some questions.
Yeah. First off, can you do you have to have the Bluefin?
No, no, you don't.
Okay.
No, you don't. Like I said, this will install on regular Linux. They have installers for Fedora and CentOS, probably Debian too. And importantly, right, actually for the project, because of what people have on their laptops, the primary targets are actually Mac and Windows.
Oh, cool, cool. And then I saw that there were labels on your images that had Podman and then Docker for kind. So does that mean that actually it self-detects what images are installed on your machine and
yes, well, because importantly, right, yeah. In each container runtime has its own local storage for images, right? And Docker does not store the images in the same place that Podman does. So as a result, actually you can see this more in containers, right? For example, there's still some issues with Podman and Kind, because Kind was developed for the Docker runtime. So that's actually running on Docker.
Can you speak to the integration between Podman Desktop and a production environment that's based on Helm file?
Based on Helm? That's actually one of those cases where you want to look at the extensions. So let's look at the extension catalog. And I guess one of my first questions is there actually a current extension for Helm? So there's not one in the core extensions. So then the question is, like, there's a whole universe on GitHub on extensions that people built themselves. And actually, hold on. Let me get to the right Firefox. Yeah, so let's see if somebody's actually built an optional one. Not getting any hits on that. I have to poke around a bit. So that might not be built yet. So that would be something to ask people about, and it might be a contribution opportunity if you're a heavy Helm user, right? Because there's no reason not to have that. Yeah. Yeah.
So when you created the ElectoPod in the desktop UI, did that generate like some Kubernetes YAML?
It didn't, because it's running a pod under Podman, right? That's one of the primary differences between the Podman desktop runtime and the Docker desktop runtime, is Podman is named that because it supports Kubernetes pods as a concept just within the runtime.
Okay.
Now,
So
what I
it's only
can
a pod
actually
by
do
name
from it
in that
is
case.
I can look at the pod that's already running right here, and I can tell it to generate Kubernetes YAML from that pod.
Okay, so that leads into my last question. So when you ran the pod on Podman, because you weren't using kind, it's not running it on Kubernetes.
Correct.
There's no Kubernetes to run it on.
Correct.
So it's running directly on Podman?
Yes.
Okay. Thank you.
Can I use this interface to manage Podman on another host? In other words, to deploy, as opposed to deploying to Kubernetes, deploy to a Podman host?
I mean, not out of the box. Is there a way you could do that, though? Probably. I have to think about that. I mean, you could certainly do a hack with SSH tunnel, because it's just sending commands to Podman. The issue that you'd run into is it sends commands to a lot of programs, as well as hits several programs' APIs. For container runtimes, there's some port access, so you need to make sure tunnel covered everything. But
so I really like Podman, and I really would love to have it be part of the local dev workflow for my team. Let's see. The question is, how can all of this interact with the changing source code repository, which might have a Docker Compose file or a Kubernetes pod declaration? I kind of want to be able to say, Podman desktop, watch that directory, watch the declarative configuration of how to make a pod locally. It might be changing over time as we pull from the source code repo, but this is dynamically rebuilding the pod in Podman desktop based on the source code repos.
oh, so you mean like you do for a GitHub action?
Yeah, because that way in version control, I don't have to write documentation instructing a junior developer how to do this, which is going to change over time as I add environment variables or something. I can just be like, hey, junior developers, point Podman desktop at the Docker Compose file in the repo, and you probably, unless something breaks, you don't have to worry about it. You can just use the GUI to launch stuff. Does that work, or does that make? I don't know. The question is really how does this interact with the changing source code over time and the differences of local dev?
And out of the box with the stuff that I showed you, it requires manual action, right? You change the source code and then you punch create image again, right? I don't know. It'd be a question if, because what you're actually getting into there is CI/CD, right? Or CI, not CD, but CI, right? Continuous integration. But could you do a lightweight continuous integration with the desktop? Interesting idea. Yeah, it would be an extension. It would be an extension that would use one of the existing CI systems because why reinvent anything? Although you could, because like OpenShift has source to image, which is like the most primitive CI system there is, but it's lovely because it's so simple, and that's really what you're asking for. So having something like that would actually be really nice, because it would, because you say, right, because what you'd want to do is you want to rebuild the image, right? You'd want to rebase any containers, and then you would want to restart any pods that were based on that, right? Let's follow up on that. Okay.
Hi.
I can take one more very easy, very fast question, and then we're done.
You mentioned a moment ago how SSH, the desktop interacts with many other programs. Is there a log file or someplace one could see the commands it uses, or perhaps their standard error if there's problems?
Yeah, there's a log file for each individual object. Hold on, let me see if I can get to... I mean, generally, honestly, usually what I do when I'm debugging, like when I run into a Podman desktop bug, is I actually start it manually from Flatpak and then just keep all of the output from it, because it is generating telemetry as it runs. It's just that because I started it via the apps interface, that telemetry it's generating is just going nowhere. It's going to dev null. I don't think it normally logs to syslog, because it does generate a lot of output. But actually, that's a good question. We could find out in just a minute, couldn't we? Doesn't look like it's going there. Yeah. No, it's not. Okay. So yeah, so you need to actually then do that when you start up Podman Desktop and make sure that you're actually capturing it somewhere. Okay. Thanks a lot.
Thanks, John.
If you think of a question later on, I will be in the Red Hat booth tomorrow morning, and I'll actually be around this room pretty much the rest of the time. Mm-hmm. Do what?
Hotel. Thank you so much, Josh, for speaking. The camera is already dealt with. We have an official camera cover on, and it is definitely, you should be able to just use everything here. Podium stand. All right, talk. Handheld. This is the handheld mic. I am talking 1, 2, 6, 7. Everybody can hear me spew nonsense from stage, which is not really too different if I were here giving the actual talk. Yep. Here's the one that wasn't working before. And I hear my own voice in the room and it seems pretty good. Beautiful. Should I keep this on off when we're not using the secondary mic? Great.
Test 1 2, test 1 2.
Oh, perfect. Right. Very cool. So you want to clip this to your belt or even pocket.
Okay, I'll try pocket first. Okay.
Cool. And then this is always tricky with the hair. Let's see.
So it goes around?
Yeah. Do you want me to hold your hair?
Thank you.
Here, I got your hair. That's probably easy.
And then I wasn't sure where the
I
ears...
think that's upside down.
Okay. Right.
So, and then, right before your talk, how can I should I introduce you? Would you prefer not to be introduced?
Doesn't matter, like Shirley.
Okay, great.
Just Shirley.
Awesome.
Thanks.
And let's see, I have these handy cards. You have the whole hour, really.
Right. Yeah, because I was like, okay.
You can, would you like to do questions afterwards or during or?
Doesn't matter.
Okay. Oh, sorry, my finger is recording.
That's okay.
Great. And so for questions, we have like a mic. In order for the questions to make it on the recording,
Okay.
we're gonna like wait and hand people the mic to ask
Okay.
the questions so that you don't have to repeat it up here. And then I have these, so if you do go over, I can hold up these cards.
Okay.
And I will remind you to wrap it up.
I think
That,
I think my talk time is not that long. Maybe, I don't know. I think I try to slow down, so it might hit like 40 minutes. I don't really know.
Yeah,
But
yeah.
like,
I mean,
when I did practices, it was only 30, so like questions
perfect.
during is fine.
yeah,
But
okay. I'll keep
but,
a watch and be ready to run.
yeah, I don't know. I don't really know. Let's just
Alright.
give it a try.
Cool. No, I'm sure it'll be great. Thank you so much for coming despite the difficulties.
No, thanks for accommodating.
No.
Yeah, I appreciate it.
It's like, you know, if you gotta do the thing, you gotta do the thing.
Okay.
Cool. So, we're almost at time. You can use any of these waters if you like.
Okay, thanks. Hello? Hello? Doesn't seem that loud. What do y'all think?
Sounds good to me.
Is it better like that? Okay. Yeah.
We're gonna wait until the timer.
Yeah, that sounds good. Yeah. You're gonna say something first, right?
Yeah, I'm just
Okay.
gonna introduce you real briefly.
That sounds good. Okay, thanks.
All right. Welcome, everyone, to the last talk of the morning section here at SCaLE. I am super excited to introduce you to Shirley, who is going to introduce all of you to OpenTelemetry. Please give her a hand.
Hi, everybody. Thanks for coming. So, getting started with OpenTelemetry. This is the story of my journey in the last few months starting to instrument an app with OpenTelemetry. My career so far has not specifically been in monitoring or observability, so I was starting from scratch. Where am I coming from? I started my career as a back-end software engineer in a large, well-established classified ads website. I started maintaining microservices written in Golang. My daily role is doing things like translating product needs and maintaining APIs, very normal sort of stuff. I did care about applications, metrics, and system performance, but observability was not my most important part of my day-to-day job. So now I work at Grafana Labs, and when I joined, I felt really excited to learn about observability. Observability is understanding the state of a system based on the data it generates. For example, at my old company, we monitored the rate of requests, number of errors, and duration of requests for a given microservice. We then visualized these in real time on a dashboard. Grafana Lab's most well-known software, Grafana, is an open source visualization tool, mostly used for monitoring systems, like my old classified ads website. I was excited to dive into the challenges in the field of observability and learn more about these distributed applications that I was working on. I was so new, though, that I didn't have a profound understanding of the challenges to make a system observable. I wanted to better empathize with users of monitoring tools, so that's why I started digging into OpenTelemetry. I have to warn you, this is not some kind of super advanced talk. I'm just telling you how I, as a primarily back-end Go developer, got started. Instrumentation is not trivial. I ran into a number of paper cuts, bumps, blockers, while trying to figure this out. I don't think anybody's free on a Friday afternoon and just says, oh, I'll just pick a quick ticket and figure out how to instrument their service in that afternoon. I'm here to share with you what I learned along the way and hope that you feel relieved if you too find instrumentation challenging when you get started. I'm also here to learn and listen. Feel free to let me know what you think and tell me what could be improved. We're very privileged, and one of the best part of our jobs is learning. OpenTelemetry is a popular open source project to instrument, gather, collect, and export metrics like data like metrics, logs, and traces. Why should we adopt OpenTelemetry? One of the project's goals is to make it easy to change between various integrations and observability backends. In other words, you could hypothetically instrument your application now using the OTel libraries and move between exporting to Datadog and to Grafana. But that's the pretty picture. I'm aware moving between vendors is not trivial, but if this is something you're interested in, you know, the ownership of your observability data, then let's start by trying to get interested in OpenTelemetry and bring some momentum to the project. After all, it's open source, so we can expect an accessible community with many friendly participants, like myself. All right, let's set the stage. What are we going to observe? Let's start with a simple Go app, some kind of API. We have here a simple service with an exposed endpoint that we'll be able to curl. Then the handler code continues and makes another external call. For that external call, I just found some GitHub API that I could curl. I could make a request to, and that was fine. But all of that is to mimic a distributed application. So I have all this deploying in Docker using Docker Compose, which helps me keep my understanding of the different components and ports organized as we add on more components to start collecting and transmitting that telemetry data. That's what we start with. What is our longish term goal? What are we trying to do? Let's get that simple Go app we just mentioned and try to instrument with OpenTelemetry sufficiently such that we can visualize traces, like in this screenshot, which is an example of traces. This is called a flame graph representation of a trace. A trace is like the path a request takes in your application. Each span, the horizontal lines here, represent a separate unit of work and the time elapsed during that action. Vertically, these spans represent subsequent sequence units of work in order of when they're called in the stack. And you have sort of parent and child spans that you see here as they're indented. So a classic example of what you might use tracing for is if you have a web shop application. You've got a customer going onto your website, they view a product, and let's say they click on that product. Then you might have a trace start when they click on the button to view. A child span begins when some kind of asynchronous call is made to another backend service, or it might be synchronous and you might be fetching that product information. And you might imagine another span is formed when another service is called in order to render images, or maybe the user is authenticating, fetching other recommended products. The root span and overall trace ends when the customer receives the response from the product information page. So let's reiterate. We had that simple Go app, and we're going to try to get to traces, to visualizing traces. I find traces visually very intuitive, interesting, and they're also very well supported in OpenTelemetry. OpenTelemetry was born out of the merging of two older but separate open source tracing projects. So you've got a pretty mature type of data here. Let's not get ahead of ourselves. The first thing we're going to do is set up a bit of a pipeline in order to go from instrumentation all the way to visualization. So once again, first, we're just going to try to get any trace data printed out into the console. Later, once we've confirmed we can generate that trace data, we can collect and start visualizing the data just like we had in that screenshot on the previous slide. Something to remember in general, not trying to lecture anybody, but when I was getting started, my mentor frequently advised me to develop a short, fast feedback loop on which we're going to iterate. I know that's not a unique principle, but something that I have to remind myself every single day. So, how do we start? We're going to need to provide some way to go from our simple Go app to generate trace data. That's instrumentation, something I've been saying. One of the first questions we ask ourselves when we start to instrument is, should we instrument automatically or manually? Kind of depends on our needs. Automatic instrumentation is designed so that without needing to modify our application code, we can get a decent amount of telemetry data. That's great because it can help jumpstart our OpenTelemetry journey with relatively little effort. Manual instrumentation means we're going to use the OpenTelemetry API, write lines of code in our application that say, start a span or log this. And the principal advantage of manual instrumentation would be the granularity and the control you can have over what kind of data you're generating. We could even create stuff that's business specific. It's not necessarily related to HTTP calls or anything like that. We could say, okay, when the user enters this function, that's how long it takes for it to fetch some other information about it, the product. So I'm going to show you both automatic and manual instrumentation. I find automatic instrumentation fascinating. It's seemingly magical to do so much with so little effort. But I find manual instrumentation challenging but rewarding, a little bit more like the satisfaction we derive from solving problems. So let's get started with auto instrumentation. Think of this as the appetizer, short but sweet. So I used an auto instrumentation tool developed by some of my colleagues at Grafana Labs. It's called Bela. It's open source and conveniently creates data in the OpenTelemetry format. Bela uses eBPF, technology that lets us observe what's happening inside the operating system without changing the code or slowing things down too much. eBPF runs small programs in the kernel, the core of the operating system, which is how it's able to collect without requiring any changes to the application code. Isn't that incredible? I think of eBPF as a way to kind of sniff what applications are doing, but from deep inside the system. I don't pretend to understand all the details, but as you'll see, that doesn't stop me from using it, and it won't stop you either. So remember, I'm deploying my Golang app in Docker, and all we'll have to do to get Bela running is run it alongside in another container. That's only 7 more lines of code in the Docker Compose, and we're all set. So we start everything up. We're going to curl the endpoint in my app to create some activity, and time for the first feedback loop. What kind of traces can we already see in the logs? These lines indicate that Bela is already tracing the service from my HTTP client making external calls, as well as the HTTP response that the app is giving back to the curl requests. So what are we able to do so far? We know we're able to automatically instrument the simple Go app, but I'm guessing that we didn't actually just want to parse these lines with our eyeballs in 2025. So we're going to need to export this data, not into the console anymore, but rather to a backend where we can store it. We're going to find software to provide a way to search through our trace data, and more importantly, to visualize it, like I showed in that screenshot. Corporate tangent time. So one of Grafana Labs' support for OpenTelemetry is its backend storage for distributed traces. It's an open source project called Tempo, and Tempo is fully compatible with OpenTelemetry. That means once we start collecting traces, we're going to query Tempo and explore them directly in Grafana. In order to make use of Tempo and visualizing in Grafana, we could add both to the stack in the Docker Compose and continue running everything locally, but I found an easier solution. Grafana Labs has a cloud service, which, you guessed it, Grafana Cloud. They've got a free plan. It's good for experimenting and getting started, and we don't have to do much infrastructure to get started. Just sign up for that free account. They provide some endpoints for receiving data via OTLP. This is the OpenTelemetry protocol, a standardized format for their telemetry data. So all we have to do is copy our OTLP endpoint, our Grafana Cloud instance ID, and generate an access token. We modify our Bela entry in Docker Compose with these additional pieces of information, and we should be all set to send our data to Tempo in Grafana Cloud. So, feedback loop time again, rebuild, restart the app, curl the endpoint for this activity, and check Grafana to see if anything has trickled in. And if you do that, you see my dozens of curls spamming that app, and that was pretty easy. Without modifying a single line of application code, Bela was able to generate traces for the GET request to my Go app. It not only captured the span for the curl to our service, but it also created a nested child span for the outbound HTTP call, as you can see there. This means we're already getting started with observability with very minimal effort. No code changes, no deep instrumentation, just instant insights. Pretty powerful. But like I said, auto-instrumentation was just the appetizer. Now that we've had a taste, it's time for the main dish, manual instrumentation. So let's see how we can take even more control of our instrumentation. But why would you bother again? If auto-instrumentation gives us such useful data with so little effort, why do we even bother? Well, aside from the satisfaction of problem solving, which I'm not entirely sure we're all that satisfied with all the time, there are some very practical reasons to go beyond auto-instrumentation. The first is granularity. Bela can capture high-level request traces, but that's about it. It's not going to give us deeper insights into what happens inside the application. With manual instrumentation, we're going to gain full control of this. We're going to be able to start a trace when we want. For example, we can measure how long it takes to process a subscription renewal, and that could affect customer satisfaction and retention. This is the kind of insight that would allow us to correlate performance of our application directly to business outcomes. Those are things that automatic instrumentation is just not going to be able to sort out on its own. Another limitation of BELA specifically is that while it can capture metrics and traces, it doesn't provide logs. So with manual instrumentations, we can capture and log important events. So let's shift gears and get into that manual instrumentation. A good place to start is the official OpenTelemetry docs. Their Getting Started guide for Go is a solid resource, and conveniently, they also use a simple Go application. The first step in the guide is initializing the OpenTel SDK. This is the Go implementation of the OpenTelemetry API, and it's required for generating and sending the telemetry data. It's the foundation of our manual instrumentation. What's nice is that the guide provides a ready-to-use code snippet for setting up the OTel SDK, and I love that it's just as easy as copying and pasting. My favorite action every single day, copy-paste. The snippet just lives in its own file, and that keeps our application code clean and organized for the time being. So what's in the OTel SDK? Remember, we're just talking about trace support here specifically. At its core, the SDK gives us a fundamental component, the tracer provider. This is the bread and butter of trace telemetry, and the tracer provider allows us to send data through the rest of our pipeline. There are a couple of objects that compose the tracer provider, the exporter and the resource. The resource is just a description of the process that's generating the telemetry data. So think of that as a metadata that you attach to your traces. The exporter is a little bit more interesting. This is where the telemetry data is sent. So there's a few choices here. You can export by HTTP, gRPC, or just dump things into the console. You only need to initialize this tracer provider once. It stays active throughout your application, and you use it again to get tracers, hence the name tracer provider. And the tracers are what we're going to use to generate those spans in the app, those horizontal lines that I mentioned earlier in the visualization. So tying all of this together, when we initialize the tracer provider, we put together the resource, the thing that's generating the telemetry data, and the exporter, the place where the telemetry data is going. The other key element of the OTel SDK is how it ties together trace data. So we're talking about distributed systems here, where multiple services are calling each other. So it's crucial to track the path of those calls. How the trace data is connected together lies in context propagation. Each service in the chain holds a context, which it passes along to the next service. This allows us to follow the flow of the request across the systems. So OpenTelemetry defines the specific format for this context, ensuring that it's consistently propagated across services. If we didn't have propagation, instead of having a single trace with a family of spans, we'd end up with multiple independent traces for each action, none of them tied together. So not very helpful at analysis time in the context of a distributed system. Once we've initialized the SDK, we can finally do the instrumentation part. Up until now, we've just been setting up the tools that allow telemetry to be emitted. Now we can use that tracer provider to get those tracers. Tracers are going to let us create spans, which represent those individual parent-child units of work within a trace. As I mentioned earlier, manual instrumentation gives us more control, letting us decide exactly where spans should start and stop. For example, one of the things we can do in my simple Go app is add a span at the start of a function call. That's your simplest example of manual instrumentation. You start it at the function call, and you defer the end of the span at the end of the function. In a real-world scenario, you could track, like I mentioned before, business-specific telemetry, like user actions or some key operations. Another relatively easy step we can take to generate trace data is to add OpenTelemetry middleware to our HTTP interactions. Remember, I said that this is a little app that accepts HTTP GET requests, and it makes an external call that's also in HTTP. So we're going to have middleware for both the endpoint handler and the HTTP client used to make those external calls. In my simple app, here's how the request flows. We start by curling the app, which sends a request to our HTTP handler. Before reaching the handler, the request passes through the OpenTelemetry middleware that I've added to the app. That's where the context propagation begins. The handler processes the request and forwards it, preserving that context again. And next, when the app makes an external call using the HTTP client, it once again passes through OTel middleware. This ensures that when the request is sent to the external service, it carries the necessary trace context. When the response comes back, it's enriched with trace information, and it lets us track the full journey of the request. By adding the manual tracer span that I mentioned in the previous slide, and this HTTP middleware in this slide, we're going to have a good amount of traces being generated with just that. We're going to configure the exporter in the tracer provider to send data to STD out. That means we're going to see telemetry logs pouring out into the console. So we're going to trigger the feedback loop again and curl the service. And let's curl the endpoint. When we do that, we're going to see a trace appear in the console output of the Docker container. That's a win. It's really, really satisfying at this point to know that your SDK is initialized correctly, that your instrumentation is working, and telemetry data is being emitted. That's like a trace in JSON format or something like that, if I recall correctly. So, at that point, the getting started guide from the OTel official documentation kind of cuts off. We don't have clear instructions on what to do beyond printing out traces to the console. To be fair, there are outgoing links to other documentation and some suggestions, but our hand is no longer being held with copy and paste snippets that were easy to use. And it's kind of a decision tree where you have a few options and you're kind of left on your own to call the shots and incorporate your choices into your code. So similar to earlier with auto instrumentation, we're going to send it to a backend storage where we can query and visualize it. To send it to a backend storage, we first need another service that can receive, process, and export that data. I'm going to use the OpenTelemetry collector. It's a good fit. It's the official OpenTelemetry supported implementation for handling telemetry data. It's designed to be vendor agnostic, and it eliminates the need to run and maintain multiple other agents. In my setup, I run the OTel collector in Docker alongside the simple Go app, and so it's, again, just another entry in the Docker compose. Doesn't take a lot of effort. Back in the simple Go app's code, what we do is we now modify the exporter to start sending to the OTel collector instead of just the console. So again, a couple of little lines of code modified there, but you have the control of where it goes. Once the data reaches the OTel collector, where is it going to go after that? Again, we have to make another choice. While OTel defined the format of the telemetry data, it doesn't provide a specific monitoring backend or make a recommendation on which one to use. Because OTel's focus is on the data's structure, and it works to support integrations with a lot of popular backends. But you know where I'm going to export to? I'm going to Grafana Labs Tempo again. No big surprise. So we've got to tell the OTel collector how to send to Grafana Cloud. The blueprint for defining that pipeline for the OTel collector is its config file. That's how we customize how the telemetry data it receives is processed and where it gets sent. So we've got a section in the file that's called receivers. This is how the collector ingests data. In our case, we're using the OTLP receiver, and that allows the collector to accept telemetry over gRPC or HTTP. Next, the config file has a section called processors. These are useful for things like batching, filtering, or adding more metadata before we export the data. Then we have an exporters section, not to be confused with the exporter in the tracer provider. Just a different exporters in the config file, and that's just saying where the telemetry data should go. We're sending our traces to Grafana Cloud, so we're going to use the OTLP exporter because I have an OTLP endpoint available. Last section of the config file is the service section. That's where we link this receivers, processors, and exporters together. So I just described all the stuff in the config file. That's what the docs looks like for the config file. But I'll be honest, I didn't really read all of this and fill it out. Just, I don't know, mind blown. I didn't read the docs here. I didn't read the docs on Grafana Cloud side because my favorite action is copying and pasting. So I went to Grafana Cloud, and I already knew about this, that there was this connection section. And what I go to is add a new connection. Then I go to OpenTelemetry collector for what I want to add. And this thing, because I'm logged in, it generates the OTLP endpoint for my region. I think it asks me if I want to make a access token right here. So I have just create an access token there, and it fills out the config file for me. It's this big snippet, like I said. And basically, you just paste that into your repo with your simple Go app, and you just refer to that file again in your Docker Compose, and you're good. So, feedback loop time again, moment of truth. Let's generate some activity by curling the endpoint. So, once you do that, you head over to Grafana Cloud, and you explore the data in Tempo. And there it is, the trace with manual instrumentation. So we got our familiar flame graph, and that gives us the detailed journey of the requests. Thanks to manual instrumentation, we can see more granular spans that wouldn't have been captured with auto instrumentation. We marked the exact moment we entered the handler, and we even tracked when I triggered a sleep event in the app. This is where manual instrumentation shines. We're not just collecting traces, we're shaping them to tell the story that we wanted. One last bit to mention, the dessert to this course is, earlier I mentioned that auto instrumentation does not capture logs, not the solution that I chose anyway. So we can add a little addition to our setup, all that OTel SDK setup that I mentioned earlier. The code is almost identical to everything about Tracer Provider. They call it Logger Provider. And we import the same sort of thing from the OTel SDK, and we can capture logs. And in this example, I just had an artificial error in my handler and logged that. And what we see here is by exploring the Loki data source, which is a logs data source for Grafana, we have it right here. So that can provide more context to our telemetry data. That's the story, starting from the simple Go app all the way to visualizing the telemetry data. But of course, the journey doesn't end here. We're just scratching the surface. With the initial setup in place, there's so much more we can explore. We can dive deeper into the documentation for best practices on creating traces and spans, and there's a lot of things here that probably aren't best practices. We can even add, similar to the tracer provider, logger provider that I mentioned, guess what? There's a metrics provider. Huge leap. And it's all analogous code. You'll see that in the Getting Started guide, it's just 3 little blocks. But again, keep your feedback loop short and tight. Don't do all 3 at once. It's pretty straightforward to keep adding more granular instrumentation where you needed. Just remember to iterate and keep that short feedback loop going. Thank you so much for listening. That's the journey. Well, if you want to see that repo where I was working on it, you can go look there, or report probably all the issues that it has. Who knows, if you need to. Yeah.
Yeah, just wait until I come around with a microphone so it's on the recording.
So I had looked at the logging functionality of OTel, and when I last looked at it, it's been at least a few months. The stuff moves fast. I was unclear on if it's production ready or not. Are you guys using it in production, or any thoughts on that? Is it just works well enough?
I think I've heard that. That's all I have to say about it. I'm actually, we make logs. It's I don't think we're making OTel logs on the parts that I'm working on, but I'm sure there's some gung-ho colleagues who are very advanced experts who are doing all sorts of things. Sorry,
Cool.
I'm not
Yeah,
sure.
yeah, no worries. Appreciate the insight.
Yeah, so I was just curious. Go is great, don't get me wrong, but what does the support for other languages look like right now? So I have a huge app in Java, right?
I didn't hear it. What's the support in other languages like Java?
Yeah, just support in other languages for this.
I don't know. I'm so sorry. I'm a really there is a long list, and I'm pretty sure Java's high up there. Isn't Java the most common backend language ever? Yeah, I'm sure that that's really high up, way higher up than Go.
We threw it together, or we're using the cloud version of Grafana, and we needed to instrument some stuff. Added the settings, added the jar to the Java ops, and we're getting the traces showing up in the service call.
Thank you so
Yeah,
much.
always appreciate it when we open source the Q&A section.
I know, always appreciated doing, sorry.
Going once, going twice. Oh.
So for OTel, don't they have their own auto instrumentation implementation?
I didn't catch it. I heard OTel.
For OTel, they have their auto instrumentation.
Other instrumentation. They have their own auto instrumentation. Right? Exactly. Yeah. Okay. I think that's something that I'd like to look into one day is comparing all the auto instrumentation options that there are out there.
Okay.
Yeah. I've heard it's not. It's a little janky or something.
Okay, so Bela is better?
No. No.
Okay.
Yeah, sorry. That's not what I meant. I heard that they're working on it together.
Okay. And then I stumbled upon the LGTM Docker
LGT. Oh yeah, that's true. Yeah, that was
maybe you should talk about
when I was working on this. I think the LGTM Docker. That's when they were like, yeah, now you can have everything in Docker, and I was like, oh, but I got everything going to cloud first. So then I didn't work with the full Grafana stack in Docker. But it's definitely possible. Probably fine. I would find that annoying to host personally. But maybe that's part of, why would you bother manually instrumenting if you can auto-instrument? Yeah, why would you use? That's a good point, like having it all running in Docker. You could have your custom Grafana images or data sources that you compile yourself. Why not? But yeah, you'd probably pull the official images, so never mind.
I'm a little sick, sorry, but I've actually deployed OTel on Go as well as Python and Java, and it's very, very simple. You just start it up in front of UVcorn or something like that, and it auto-instruments everything.
Yeah, I'm not catching the end part.
Oh, what I'm saying is just use the OTel collector, and you can put any backend you want on it. The OTel collector for us goes to New Relic. So basically, you need a collector on the basically either a sidecar or in the same cluster, and then everyone just pushes all their Java, or their Go, or their Python, their Ruby, whatever it is, and then you pick your backend that you want. Like Honeycomb does that, I think, and I know for sure New Relic does that, and I'd like to find out what Datadog is doing because they're not so happy.
I didn't catch a lot of that. I'm really sorry.
I think it was really more of a comment on what's possible, yes?
Oh, yeah. Just a demonstration of your expertise. Oh, yeah. Yeah. Yeah, definitely. Yeah, this is not just, this was like my bad story about my Go limitations. Yeah, thanks for sharing.
All right. Well, thank you everyone for coming. Let's give another big hand to Shirley. Thank you so much. Enjoy the rest of the conference.
Thank you. Yeah, there's a Grafana booth with more, I don't know, seasoned users if you have any questions or you want to just chat with other Grafana people. Thank you. That's okay.
Oh, you got it already. Okay.
running long distances really, really slowly, singing everywhere I can, and I'm active in lots of other communities as well. And fun fact is that last summer I was a torchbearer for the Paralympics in Paris, and here's a picture of me holding my torch in our Portland Airbnb office. And the bottom, thank you, thank you. And the bottom of this here is the most important, other than this great picture. Hold on, is this on? Is this still working? Did I just, hello? This is live, people.
We're troubleshooting in production, so y'all can relate. Anybody else been there?
Let me turn it off. Hello? Did that do it? Hello? You can still hear me? Okay. All right. Yes, all the opinions in this talk are mine, not my employer's, important to say. So, this is my friend Muriel.
Hello, everybody. you progress into the outer loop. And that's really everything that happens from when your code is getting committed to this going out and actually being available to run and operate in like a staging or a production or some other type of environment. So that's like really where you're doing the operations, your deployment, your release, and so on. And this is something that happens kind of over and over again. It's an iterative process. So you're going through your inner loop, and then it kind of hands off to the outer loop. And these are the things that are just generally happening as you're going through the software development lifecycle. So if anybody has felt overwhelmed in narrowing down your choices, you can see this is, even this is just a little snapshot of some of the different tools and technologies. Some of you, maybe like myself, have come from the sysadmin world. Much been evolving, and so maybe you have had titles or have worked in fields or have done things that maybe now fall under what you think of as platform engineering. Has anybody been hearing a lot of buzz around platform engineering recently? Or SRE, site reliability engineering or release engineering. Well, there's still a lot of these same practices that just relate to how is your code running in production, or how do you get your application out to your users. So as you can see, there are a lot of different decisions that need to be made. Everything from where are you hosting? Is this going to be local in a data center on the cloud? What type of version control system are you using? Any of your dependencies, your database, domain and DNS. Like there are a lot of these different components. Everything through how you're taking care of security. Like we mentioned earlier, like Elizabeth mentioned, we're really keeping this very scoped, beginner-friendly, and just focusing really at this end part with your CI/CD system and some of the tools that you can use for deploying to Kubernetes. So first, let's look, before you get to the Kubernetes side of things, what a basic deployment process might look like. You're in your IDE, you're working, you are saving your code, you are hopefully committing to a version control repository somewhere, and then from there, you can see there's maybe some kind of build and deploy process. Maybe this is automated, maybe you have some scripts, maybe you have some artisanal code that's getting updated and values copy pasted before it gets sent into a production system. But essentially, you have code, you have some pieces that are getting built, and then everything eventually lands on a server or some system that now is available to other users of your application. So when we're looking at Kubernetes deployments, there's a little bit of additional complexity that gets added in. So you have your application code, and from there, that code then gets built into a container. Usually you'll have something like a Docker file that maybe lives with that application code and gets sent over to a build system. So from that build system, basically you're a container and your image is getting built, and often that will go into some type of artifact storage. And so that is something like you may have used Docker Hub. There are a lot of other places where you can have artifacts stored, and usually those will be the fully built container image or sometimes a Helm chart, which we are going to talk about later. And when that image gets built, you get some kind of link or reference that points you to that artifact so that when you deploy your application, you don't have to go through all that build process. You can just say, hey, let me pull that image or that application or that thing that has been built previously. And then from there, somewhere you will, maybe in the same repository or a different one, have your actual application configs. And so for those of you that have been working with Kubernetes, often you may have dreams and or nightmares of YAML. So you'll have all of this YAML that has your definitions of your application itself, the deployments, the pods, and so on. And those are the references that are used to be able to then deploy that image that was built or whatever resources into your Kubernetes cluster. So that's some of the different components that go now into this workflow when you're deploying into Kubernetes. So another thing to note, if you see there at the bottom, there are kind of two paradigms, I think, to think of. One is the push-based method, which is generally imperative, and you may have seen this, like where you run a script, or you execute a pipeline, or you do a task, and that says, basically, you are like commanding the system to do the thing that you're asking to it. So you're running a command, you're executing something, and that similar effect is happening on the cluster. But the other paradigm is this pull-based method, which is generally imperative, which means basically, kind of following this Kubernetes resource model is that you declare the state of things. And so in the declarative model, you say, this is the standard of what my application can look like. And there's this reconciliation loop that happens to get what is running on your servers or in production to mirror the state of your configs that live in version control. And essentially, there is something usually that will be running, maybe in your cluster directly, that will check to see what your desired state is, and it will match the running state to that desired state. And that's generally better because rather than saying, hey, let me execute these series of commands, maybe there were some things that were injected, it's a lot easier to see and refer to your configs to know and have that version controlled so that you can continually have that loop and be able to better understand your production systems.
So, why are there so many different types of tools? Why would we need to, what are we doing? Why do we need all these different things? I like to posit an analogy here for everybody, okay? So let's take getting dressed for your first day at a new job, okay? So you pick out your outfit, and let's say we'll call that Dev, and then you might ask a friend what they think about your outfit, and we'll call that version control. And you probably want to try your outfit on, let's call that staging, and then you wear it out. That's prod. So there's a process that works there, okay? And you know how to get out the door wearing something, okay? But let's consider what would need to change or what you might want to consider if your new job was, say, as an ambassador to the UN, all right? There's some other things you might want to consider, some other tools you might want to use, like checking the weather, for instance, okay? So maybe we'll call that a developer workflow tool. You go check the weather, you figure out what you're going to wear, what you might change. You could check the dress code. Maybe there's a dress code, so maybe a templating or a configuration tool in that case. And you'd probably want to bring a backup sweater in case it's cold at the UN, but maybe it's just cold there, who knows. So you consider that your outfit is going to be viewed by heads of state, and people all over the world might depend on what you're wearing to make a statement, right? To be the face of your nation or wherever you're coming from. So you can pick your outfit and go with it, and it works, but you can see that in certain environments, standardizing tools and added specific configs may be needed to achieve a desired result there. And I guess in the case if you're showing up on an enterprise team that has all its tools already set up for you, maybe the analogy is it's a uniform, who knows? I'll leave that for you to decide. So in the remainder of this talk, we'll start, we have some tools that we're going to introduce and walk through, and we'll start with the developer workflow. We'll take a look at Scaffold, and then some templating, packaging, and configuration tools, Customize and Helm. And then finally, we'll take a look at 4 common CI/CD tools. And there's a lot to discover about each of them, and we'll cover the basics for you with introductions, key concepts, and highlights. So stay tuned, and resources will all be at the end of this deck. So what goals do these tools all have in common is they help you get your code to the world.
So to start off at the very beginning, let's look at just your manual deployment methods to be able to get running applications into Kubernetes. There are some assumptions here that you already have a cluster that is set up and running, whether locally or in the cloud. Locally, maybe that's like a Minikube or Kind or something to that effect, and that you already have all of your credentials and everything set up to be able to access that cluster using kubectl. That's what I'm sticking with. I know there's kubectl, there are a lot of different ways of slicing this. Philosophical debates can happen later. So this is what a very basic manual deployment might look like. And what's essentially happening here is that we are running kubectl create, and we're actually just sending the YAML directly over within the command line. So if you find a snippet on Stack Overflow or maybe auto-generated through some code, and you're going to YOLO and hope that that AI code works with the YAML generation, so you can actually just send that directly over you can also have that file created as well and send that in as well. And one thing to note is that when you are running this specific command, and there are some different ways to be able to run an application on Kubernetes using kubectl in this imperative way, create is assuming that you are creating a new thing. So if you run create and you try to rerun this, you'll get a complaint because Kubernetes is going to say, well, you can't create it, it's here already. So some other methods of being able to do this manual deployment is running the apply. And apply is kind of going down that declarative route where you're giving it a file, or you can also point an entire directory, and any of the recognizable YAML in that directory will now get applied and sent into your server. And when you're doing that, it will basically kind of reconcile the state. So if you do have a resource that already exists, it'll say, fine, nothing's changed, like deployed, unchanged, you're good. But if there are new things in there, or if there are updates, it will update to that so that you know you can rerun as many times as you need to, and it will basically just say, we're gonna match the state of what's in the cluster to everything that is in this set of files. And then there's also another method of being able to send something over. Basically, when you're doing the apply, it will take a look at the type of resource that is defined in those files and create those. So maybe that's deployments and services or a whole bunch of other tools. But when you're doing run, essentially, that's just going in and setting up a pod. So it's going to be a little bit more ephemeral in the state of, like, if you have a deployment, you know, basically it will say, hey, keep these pods, this is what the deployment should look like, keep your pods up and running. But if you just do kubectl run, and you can actually just pass over the image directly, like we were talking about your artifact repository, you can just point that link to an image, run that directly. You can even do things like expose that port so that it is actually available and accessible through the network. But when you kill that pod or when you delete it, it's just gone, right? Versus a deployment where it will kind of continue to reconcile and create and make sure that all of the resources or the pods within that deployment are still up and running. So we just talked about some of the different manual deployment methods. Now we're going to look at SCaFold. And this is an open source tool. It's a developer client-side tool. It was once upon a time developed at Google, and it really simplifies and streamlines the development workflow. And what this does is it just makes it a little bit faster for you to be able to be up and running in a repository so that you can start working on a feature versus you might have seen that workflow with the development process. There are a lot of things that need to happen before you can just send something over if you're starting from scratch with your code or application. You're gonna have to do things like Docker build so that your image itself is built. You might have to do some tagging, pushing that image to a repository, editing some manifests maybe, applying the file, doing some logs. Well, SCaFold really simplifies that into one workflow so that you can just run one command, for example, SCaFold dev, and you have all of these steps, the build, tag, push, etc., defined, and you can have it defined on a per environment basis so that with that one command, you can now go through all of those steps that have already been defined in this workflow. So essentially, it really helps when you're trying to do some client-side testing, and you don't want to have to worry necessarily about all of the things that need to happen or remember all of that. And also, if you're doing things across different environments, you can have different profiles, like I want something to happen if I'm deploying locally, or if I'm deploying into my staging environment, use this separate set of parameters.
Taking a look at a different tool, Customize. Customize is a config tool or configuration tool that provides a solution for customizing your Kubernetes resources without using templates. So it simplifies your configuration management by allowing customization without your templates. It uses a base. The main concept here is a base and an overlay system, making it easy for you to manage your configuration, manage configurations for your different environments, like your dev, staging, and production. And you can generate resources like your config maps and your secrets directly, which is handy for storing your config data. And finally, it's great for combining and customizing sets of resources, so keeping things organized and flexible. And check the docs for your kubectl version because there are a couple different ways to use it. So the key concepts I mentioned, the main one to take away is layering. So a base is where we define our common settings, and developers use overlays to make changes to the base for their specific environments. And then you can use patches to make changes without touching the original configs. So let's take a look at a written example from our demo app, and we'll show it at the end. So here it is written out. So taking a look at how our example Where Am I application uses customization. So here's a snippet of the file structure on the left-hand side. And what you'll see is the Kate's directory customization file is pointing, the arrow there is pointing to the resources at the top. The arrow is pointing to the resources that are declared in that file. So your service and your deployment and the config maps, etc. So the concept of overlays that I mentioned is to manage a configuration variant like your development or staging, etc., to modify your common base. So in this code snippet example, we're creating overlays for our backend and a front-end overlay. So an overlay is just another customization.yaml file that refers to your base, and you can see that in red on the lower right-hand example. So resources, you see it referring to the Kates, and then with patches, you'll see the specific things that we're going to be changing. So this arrangement makes it really easy to manage your config using Git. And we can see in our example, all the resources are written out exactly or as references, but there's no templating. So taking a step back for everybody here, like why would anybody want that, or what's a template? So for everybody, we're at a beginner talk here. So like the visual example of a templating pattern. So a templating pattern in the context of Kubernetes and YAML refers to a method of creating reusable and customizable config files for your Kubernetes resources. So this approach allows developers to manage complex deployments more efficiently by reducing repetition and enabling dynamic generation of your Kubernetes manifests. So customization key feature is template-free YAML. Why would an engineer like that? Why would an engineer like that? Because you can see exactly what's defined in your base and your overlays. And our next tool that we'll look at is Helm, which extensively uses templating. And some people love that. Why? Because you don't need to manage the files in all the environments. So it's, there's advantages to both approaches. So let's take a look at Helm next.
Thank you. So when we think about Helm, essentially just think of that as your package manager for Kubernetes. So similar to things like apt or yum or homebrew, etc. It's been around since 2015 and really helps to manage your Kubernetes application. And so it actually does a little bit more than just the config management and so on. It can actually be used to manage releases and so on. One thing to note is that specifically here we're going to be talking about Helm 3. You know, there's a lot of docs on the internet about just different patterns and things. Essentially, Helm 3 is client side, where previous version had this sort of like server side component. So one of the benefits with Helm is that it actually helps with deploying some complex applications. So if you're looking to deploy a tool like, for example, any one of the CI/CD tools mentioned, there is likely a Helm chart that is available for that. And what that does is it basically helps you to define an entire application or application stack. So if there are other components beyond just this one specific piece, like say there's a data layer or maybe there are some other dependencies, you can map out those dependencies and it'll essentially sort of package that all up so that it's a little bit easier to get started quickly. So oftentimes, rather than having to build and run everything from the ground up and figure out what all of the different components are, you can use the Helm chart as reference or maybe as a base that you can then start to make your own specific modifications on top of. And another thing too is that one, as you saw previously, Customize is integrated with kubectl, especially the current versions where you don't have to use a specific separate command line tool for that. But you can also use Customize on top of Helm, and so these will kind of interrelate. So if you say, hey, I want to have my charts as the base, and then you want to add some overlay configurations on top of that, then essentially it's kind of additive, where you're like, here is my base installation of, like, say you're doing a stateful app like Postgres or whatever, or you want to deploy Jenkins using Helm, and you have your specific configurations. You can have those defined as overlays and say, take the upstream, the standard, updated set of packages that are out there, and then apply my changes on top of that. So charts, as mentioned, are this collection of files that describe, all of these different resources. So it makes it easy to be able to start versioning. And some of the pieces that you will see as a part of a chart are like your base manifests for your Kubernetes resource. Templates, as mentioned, so you saw those different values. There are places where you might have certain things injected, like maybe those are specific names or some other metadata or tags or whatever that might be there. You can have a values file, and essentially the values are just sort of key value pair for those specific templated items, where you can say, as a base, these are my defaults. And those values will pull from that values file. So you can have like maybe values per environment or per team or whatever that might look like. You can also pass values in via the command line as well. So that's another thing as a cool override. If you're like, I'm going to deploy this app, maybe you just want to test something that's one-off and say, all right, let me just name this as something-test. Then you can actually just override that value without having to go in and mess with that file itself. And also there is a chart YAML, so you can have some metadata about the chart itself. One kind of cool thing is that if you set up some data, you can actually have, like, if you wanted to have a message of the day, for example, or like some starter message when you deploy the app with like getting started text, you can configure it so that when that chart gets rolled out, you can have, hey, developers, this is what you should do next now that you have deployed this chart. So setting up Helm to install a chart, if you are on a Mac, you can actually use Brew to install Helm, so there's some kind of infinity loop happening of package managers managing each other. You can search both the public hubs and repositories that are out there. You can have specific repositories, so there are a lot of places to be able to get these artifacts, places that have been already developed, or if you have a specific corporate or maybe your own that you want to have private and not available to the world, you can actually install from these private repositories themselves. And so we'll look at this a little bit as well when you do the demo. So essentially you can, as mentioned, search for resources, but then also use Helm to be able to do actual installations and releases and so on against your cluster. And back to Elizabeth.
A brief pause to talk about a pipeline. Now's a good time to introduce this concept, as you'll see it as in the remaining tools that we covered today. So a continuous delivery pipeline is a structured automated process that facilitates the rapid and reliable delivery of software from development to production. So what's a pipeline about? It's a set of tasks executed in order. In an order, a specific order that you say. So a pipeline has built-in support to help you identify issues for your common tasks like build, test, and deploy. It has both parallel and conditional execution. It could create an audit trail, and they generally cover 5 stages: source control, build, test, staging, and finally deploy to production. Raise your hand if you've heard or used Jenkins. Thank you, everybody, and those of you who don't have your hands up, we're looking at you. And internet, that was everybody's hands. We all know. We're going to start our brief tour of CI/CD tools with Jenkins, which launched in 2004. And if you can believe it, that predated Kubernetes by 10 years. So what does Jenkins do? Jenkins is used to automate your various aspects of the software development lifecycle and building your pipelines. Some key features of Jenkins. It's extensible. Jenkins supports hundreds of plugins, allowing integration with virtually any tool in your CI/CD tool chain. It's a self-contained Java-based program that runs on Windows, Linux, Mac OS, and other Unix-like operating systems, so cross-platform options. It has a web interface, so you can check your on-the-fly errors, and has built-in help for easy setup and configuration. And Jenkins offers distributed builds, so it can work across multiple machines, enabling faster builds, test deployments across your platforms. So there's different styles of, 2 different styles that we'll cover of Jenkins pipelines. There's scripted pipelines, declarative pipelines, and both serve the same purpose, but cater to different needs. So scripted pipelines, best suited for more complex workflows requiring detailed control and customization. And declarative pipelines are a newer feature and preferred for simplicity, readability, ease of maintenance, especially in standard CI/CD processes. So for many projects, you'll find that combining those by using declarative pipelines with embedded script blocks can offer the best of both worlds. If you can see on the right, here's an example of a Jenkins declarative pipeline, and it doesn't look like YAML because it's not YAML. That's Groovy. That's Groovy syntax. And we all get to say Groovy out loud, everybody, so that's cool.
Groovy.
Groovy. Let's take a look at our next tool, Tekton. So Tekton launched as part of Google's Knative project. It originated as the build system for the Knative serverless workload platform, and later converted to a standalone project and donated to the Continuous Delivery Foundation. So Tekton runs as an extension on your clusters and provides a set of reusable components for creating your CI/CD pipelines. You can create and run your tasks in YAML, and you can manage those runs using its CLI TKN. It's down there at the bottom in green. It also has a GUI dashboard. Breaking it down to some key concepts. So a step is the most basic unit, and a task is a collection of ordered steps. So useful for simpler workloads such as running a test or linting. And a single task executes in a single Kubernetes pod, uses a single disk, and generally keeps things pretty simple. A pipeline is a collection of those tasks, useful for your more complex workloads, testing, building, deploying your more complex projects. There's also a concept of triggers, which are event-based pipelines, which we're not going to cover, but worth noting. So we'll take a look at an example, a written example here of setting up a task run. So these code snippets are also in the demo repo that you'll see. So let's use a step and a task. So represented in the task, kind task on the upper right, you'll see it's represented in the API as an object kind task. It defines a series of steps, which you'll see highlighted in red steps. So there's a little shell script there, or it's like, hi. And every time the task runs as a pod, every task runs as a pod on the Kubernetes cluster, with each step running in its own container. So first, described here, right, in the green, like, oh, I made a Hello World YAML file task with a step that includes that Hello World script. And then next here in green, I applied the YAML. And we have some taskrun.tekton.dev/hello task run, and we see that it's created. That's the output from there. So next, I made a task run object in the Hello World run YAML. And, oh, you see that there, kubectl apply. Whoop, that's the file. That's what I meant, sorry. And we apply those changes to the cluster, and then the task run object, kind task run, you see it in red there. So then you'll see that that object instantiates and executes the task, the one above it. So we create our task, it has a step, and then the task run object runs that task. task. So that's what's happening here. And then you double check your kubectl get task run. Did it do it? Yep, it succeeded. So let's take a look at another tool.
All right, so now we are moving on to Argo. And Argo broadly, it was a project that had kind of come out of Intuit, but it's an open source tool. It's actually a collection of tools. The one that we'll be focusing on today in particular is Argo CD, but just know that there are some others out there for workflows, events, and rollout management. So we are going to be focusing on this CD part of things, the CD part of the CI/CD. So essentially, Argo takes this Kubernetes native way of being able to approach continuous deployment and delivery, where all of your application definitions, your configurations, your environments, and everything are declarative. Everything is version controlled, and that just allows for better visibility, versioning, logging, understanding of what the state of your environment is. And so using this Kubernetes resource model, similar to the way that everything in Tecton was kind of defined by these YAML and these different objects or resources that live in your cluster, it's kind of the same thing with Argo CD, where essentially you can see there are actually several integrations for different tools as well. And there is an Argo component that will live in your cluster and take care of that reconciliation loop that we talked about. So if you have your code going into your Git repository, there are some of these hooks that are watching to see if changes have been made. And that API will take care of making sure that everything that is in the cluster, your applications, your configurations, and so on, are going to match the state of what gets put into your repository. So you have your single source of truth. And you can see here, these are the kind of the different components, the API server, the repository server, and in the controller. So you can actually run this directly in cluster if you wanted to have everything self-contained. If you're just doing things in sort of this development way, you can have a separate management cluster as well. So if you wanted to say, I've got multiple clusters and I want to take care of reconciling the state of everything to these different clusters, then you can have that separate cluster. Or you can have maybe a mixed model where you've got a cluster that's both management and running applications and so on. So it's really flexible in that sense. So if we're looking at some of the key resources, you can see, I guess here, the example of what that might look like. So you'll have the definition of an application. You can also have a project, which will be a group of applications. You'll have a definition as well of the repository where everything is being used, and then the actual application manifests themselves, which can be managed using things like Customize or Helm, or if you just have your standard YAML, Argo will basically take and say, let me look and see what's happening in your repo. So once you config something or once you push that out, I'm going to make sure that the cluster state matches what I'm seeing in that repo. And you can have that defined off of like a branching model or however you would like that to look like. There's also just like a grouping of applications, these app sets and projects, but we won't talk about that. Essentially, that's just as your environment grows, you have flexibility for being able to be really granular about how you define this, your layout. Just a little notes about setup. You know, it's actually super fast if you wanted to deploy and test. You know, create a namespace. You can see here we're just going to apply directly from this file that is out there and available for the installation. And from there, you just kind of walk through. You can, you know, have everything up and running in a short period of time to be able to test. And you can use both the command line tool, Argo CD, to be able to manage everything that way. So if you wanted to hook into another system that does some scripting, you can do that. Or you've got the dashboard or API and so on. So there are a few different ways to be able to work with and interact with Argos. But you've probably seen a lot of info out there as it's been really picking up traction since it fits this very Kubernetes-centric model. So if you're doing a lot of things in cluster, then it is kind of a natural extension of that.
And as our closing tool for our speed run, we'll go full circle and reintroduce you to our friend Jenkins. This time it's reborn as Jenkins X. So Jenkins X manages multiple environments using the Kubernetes namespaces. So introduced in March of 2018, Jenkins X builds upon the Jenkins automation server, but is specifically designed for your modern cloud environments. So what does this mean? The entire Jenkins X ecosystem revolves around Git, using a clustered Git repository to manage your installations, extensions, and applications. And by default, Jenkins X uses Tekton for cloud-native pipeline orchestration. Remember we went through Tekton earlier? But it can also work with traditional Jenkins pipelines for users with legacy workloads. So it incorporates chat ops functionality, which allows developers to interact with pipelines through comments on pull requests. Jenkins X offers both a CLI called JX and GUI options for interacting with the system. Something that I thought was really neat about Jenkins X is that it automatically creates a preview environment for every pull request, so developers can see the impact of their changes before they merge them. How about some key concepts in a cool diagram? So key concepts, we have source repositories, environments, and pipelines. So source repositories are a Kubernetes custom resource which create the file structures and set up the tools. Environments, like your dev, staging, and prod, are a Kubernetes custom resource in Jenkins X where the application code lives. And then we can't forget pipelines. Jenkins X creates pipeline activities for jobs, and they are a Kubernetes custom resource scoped to a namespace. And the pipeline activities are made up of steps. So a step can have 3 different kinds: stage, preview, and promote. So yeah, looking at or using your single command operations, you can create Git repos, webhooks, and CD pipelines. And another interesting feature for Jenkins X was their chat ops. So operating code changes, pipelines, and Git ops promotion via chat. So from their docs, here's just some interesting examples that they had. So more specifically, this is usually done by commenting on your pull requests on your Git provider's website. But in the future, maybe this could be Slack or a web console, who knows? So what tool should I use, or how do I set this up?
Well, Elizabeth, I think the answer is it depends, as is mostly the answer for a lot of the tools. So we are not going to be prescriptive here. Often the best tool depends on maybe what you're given, what your team is already using, or existing expertise. Like some of these tools do require that familiarity with the Kubernetes ecosystem, or they're using that resource model. So having some of that prior knowledge is helpful for being able to use that. I think essentially it's being able to start with like an understanding of some of the different developer workflows that are available and being able to apply that broadly to these different models that we talked about before, like the push versus pull model, the imperative and declarative model, and this idea of having pipelines that take you start to finish through your development lifecycle. So I won't spend too much time on this summary. This just looks at, what some of the features of the different tools are. But just to highlight again, essentially a lot of these work together because they kind of span different stages in this inner and outer loop of development. So Scaffold, for example, as mentioned as a developer workflow tool, works so that you can deploy using standard kubectl under the hood, or your rendering is happening with Helm and Customize. Same thing with Argo, Jenkins and Jenkins X. Some of the differences will be whether it's kind of doing things in this still behind the scenes kind of imperative way where you might have a Jenkins pipeline and it's essentially calling things like kubectl under the hood and running these tasks in sequence, where there may be others, like Argo, for example, that is taking the state of the repository and just doing this reconciliation loop. And also, as I kind of had mentioned earlier when we were talking about Helm, like everybody gets a Helm chart. So all of these tools already have these charts that are available that you can use. So if you did want to say, let me do a quick start install, use some sensible defaults, hopefully, then you can just go and look for that chart that's out there and install that on your cluster. So you can install and remove in this sort of lightweight way without having to invest in it too much and at least be able to kick the tires on some of these things. As a takeaway, there are going to be some resources available. But we also have almost 10 minutes left, so a little less time than imagined for our demo, but we do have a live demo that we were very committed to being able to send our hopes to all of the network gods about. Oh, I think the last thing too, as just a quick note, this was born out of a KubeCon 2 years ago where we first met and started just brainstorming and talking about tooling and geeking out over tech, and that's what kind of led us here. So,
make time to meet friends. They're here. Your people are here.
We are also going to have a little bit of a display setting switch. So let's see if this works live.
Everybody take a deep breath while we prepare for this live demo. Everybody, ready?
All right.
We're going to let it out.
Huh. Here we go.
All right.
And let's see if, okay, it's still running. I'm just going to do a quick. We had considered using some terminal recording tools, but we wanted you to see this running live and in production. So here we are. Here you go, because the thing kind of like slides. So I will hand it off to Elizabeth to start out with everything. And we actually have the markdown for our demo inside the repository that we have with demo stuff. So if you wanted to walk through this entire thing on your own, it's command by command is here for you.
Awesome. So we chose to start out with our demo using Minikube, which is your local Kubernetes cluster. I really like starting with things small and so that I can play around and touch them before I send things off into the cloud. Plus, we weren't sure about the internet. So here we are. So Minikube, there's a link here. You can go to the project website. It tells you how to download it. We're going to skip that. That's an assumption you've already done that because I don't trust the internet here. And another assumption is that you have Docker Desktop open or your the other tool, Podman. Sorry, everybody. We're using a different laptop. I have Docker, and Muriel's laptop has Podman, and I couldn't remember the name. So here we go. Let's get started with this live demo. All right. So assumption is you have your Minikube downloaded, and you have Docker or Podman, and we're going to do Minikube start with a space in the middle. There's a space. There we go. Okay, so here we are. And while that's doing something, let's take a look over here. You can check out our awesome repo that we've worked really hard on that you can have fun with. So this is the original app that we forked from, and here you'll see our demo stuff and changes and things that we've added here in the Where Am I CDCD category. Just enough traveling talk. All right, so it's updated, we've pulled. Okay, kubectl is now configured to use Minikube cluster and default. So to run Minikube using Podman and Cryo, here we go. I'm going to copy and paste this awesome.
Okay, oh, we don't need to run that. We'll just skip to the run.
Oh, God, yes, pardon me.
Yes.
Here we go. Da-da-da. Okay, we're going to go straight to the run, which we saw. We talked at the beginning of this talk about the different ways to get started. So we're going to just straight up run that image right there. Boom, we exposed a port. You can see the service Where Am I has been created, and our pod has been created. So let's take a look. So we'll take a look here. We'll take a look. Okay, cool. There's our Where Am I pod. It's running. It's all ready. Let's go. Okay. And Describe offers for everybody that is like, oh, kubectl, what is it? So Describe will give you a much more verbose look at what's going on here. So I like to read through that too. So you'll see there's a ton of information here about what's going on. So, and what I just really wanted to highlight was, here's the image. Ta-da, there you go. So it's super easy to get started with your local cluster and start playing around with these deployment tools. So we'll take a look at Customize next. So in our Where Am I application folder, we have examples using Customize to deploy overlays on the K8s base layer, which is right here. You'll see K8s, and then we have some overlays that we'll run through. So we'll go through two different ones. So we just looked at our pod. Let's apply. So we'll use the kubectl apply K8s backend overlay example. I'm going to copy and paste this. Friends, this is my first live demo, so this is very exciting for me. Thank you, thank you. Yes, I really appreciate it. Please make that go away. Oh my gosh, it deleted that thing. There we go, all right. Please do it. Yay, oh, I'm in the wrong directory.
Yes,
sorry.
So we have to.
Oh my gosh, this is so real.
Yeah. Okay. Oh, so we have to. Yeah, go into the Where Am I CI/CD directory. I forgot to add that in. Where am I?
This is why you're here, right?
Yeah.
To see this part? Okay.
Everyone loves troubleshooting in production. Right? 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 No, not so much.
Nope, too far. There we go. Let's go. Yes! Whee! All right.
Okay.
All right. So we applied some custom overlay. We have a backend now, so you can take a look. I know we're running out of time, so you can take a look at what has changed, the different config files, what we did here. So it's all in this demo. But what I really want to do is show you. You can see. So now we have a Where Am I backend. And here's our Where Am I. All right. And so nice. Make it twice. Give me a chance to redeem myself. And we'll do the front end. And I'm just going to push backspace because now copying and pasting has made me doubtful. OK. Ta-da! OK, so now we have a front end too. Excellent, excellent. Boom. So there's our front end. There's the back. And the Where Am I. So cool. And again, you'll see that basic pattern. There's our base K8s and then the overlays. So some Helm. Muriel.
Amazing. So let's talk about Helm. As mentioned, there are a ton of these public locations. One of the biggest ones is Artifact Hub, and that's kind of built into Helm, where you can just go in and do a Helm search hub. But what happens when you do that is you will get a lot of stuff because there are a lot of images in there and available. I'm actually going to exit. It only returns a few of them. So let's try to search for something specific, like Argo CD. If we do that, you can see it also still gives us a ton of stuff, including some of the official Argo and others. There's this keyword system that it has kind of some documentation, but also you may feel some heartache if you're trying to do that to find something specific. So another thing that you can actually do is add a specific repository. So if you wanted to not look at the dictionary right now, but pull in a specific official repository, then you can do that by adding, essentially I'm going to add in a repo, this is an arbitrary name, with the link to where all of the charts are, and it looks like I already have that. So when I go in and say Helm repo list, essentially it will show me the different repos that are available, and now when I do a Helm search repo, Argo CD, it will give me a much more sane number of results so that I can see just maybe some specific smaller number of curated charts. Kind of the cool thing too is if you've got multiple repos in your system, you can see all of the images that you have available. So you can add multiple, and the searching capabilities with a repo are a little bit better than the ones that are just available for the main hub. So you can go in and pass a specific version, or if you wanted to live test your regex, you could actually pass in some regex to look for something very specific. So if you do want to integrate this into a tool, you can now start to do a lot of fun combinations with being able to say, hey, I want to look for something specific, or I'm doing rollouts, and you know, you can figure out how to be able to manage just different versions that are getting rolled out. So we can also, as I mentioned, if we wanted to do things in this sort of imperative way, you can do a Helm install. I'm getting a note about my copy pasting. And so essentially, I think I am missing a release namespace that needs to be set to default. So I'll pass through that, but essentially you can install directly into a namespace, and what I'm missing here is that I already have a namespace default, and I think it's complaining because I'm trying to install where am I into an existing namespace. So I'm going to do home. Oops. Okay, awesome. So, sorry, that was a little more fun live excitement.
Yeah, love it.
We've run through this demo a couple times, so there is a little bit of like the rolling back of existing resources that was happening. So you can also go in and show the values. So we mentioned earlier that there are specific values that are associated with the chart. And so you can see here, these are some of the things that can be set, like a service type if you want a load balancer, cluster IP, or whatever. You can install from that repo directly, which is what we did here. Or if you have a Helm chart in your version control repo, you can actually just, as shown here, point to that specific Helm chart and install from that. If you wanted to pass in values from the command line, you could do this thing here, like just passing the actual key value pairs from the command line. So you have the ability to do overrides, and as with a lot of things, what is set on the command line will override whatever you might have in your config. So it's going to explicitly say, that's the thing that I need. So you can also go in and Helm list all namespaces, and it will show you what your different installations and releases are, and so on. And then hopefully I have a little bit of time for, yeah. Okay. So we did not have a chance to show Scaffold, which was actually really fun, but if you wanted to test this in your environment, you can.
It's all set.
Yes.
It's there.
But we did make it through almost all of this. So thank you all for being here. Thank you for listening to our talk.
Thank you both. This was a great talk. Really appreciate it. Yay.
Yes. And since we are out of time, if you have any questions or anything for us, then just come see us down here at the end. All right. Thank you so much. Oh, we'll have to do questions down here.
Please feel free to come up and chat with our speakers. That's what SCaLE is all about.
Oh, you're very welcome.
I have a question. I understand some of these concepts, but I'm pretty new to actually going like creating like my own deployments. What bothers me is like the concept of like seeking templates and configurations. I wanted to know what do you think? So, for example, I saw that there's like AWS created SDK, using like an SDK to like a programming language to create deployments.
Yes.
But I don't see that it's commonly used for those kind of things.
So there are a few different pieces. There are some tools for automating the deployment and management of your clusters, like all of the infrastructure pieces themselves. So like CDK or Boomi or Terraform or Deployment Manager, there's some of these things that could be used for that part, which is like, here's what I want my cluster to look like. It fixes, email it to you. Thank you. Yes, thank you so much. And so there's kind of like the infra management part of it, and then there's the application deployment piece of it, which sometimes some of the tools can, sometimes some of the tools can be used for the same things, but there are kind of two things like
the clusters themselves and then the applications that live on the clusters.
Yeah, I see what.
Okay.
The separation that you mean, but what I mean is, okay, there is the end state of the configuration that is going to be sent to, and then let's say my application is really complex and
Thank you for the suggestion. I hadn't thought of that. Yeah. Thank you so much.
I thought in some cases that the templates get to be very like boilerplate. So okay, maybe I'll write like I can write something and not do you use declarative. But so you're saying CDK is more like specifically more for
Yeah,
infrastructure?
so I haven't worked with Amazon CDK specifically, but from what I understand, it's a little bit more on the infrastructure management piece of it than the application. But something like, some of those app tools, you can actually have a piece in the scripting that's like, oh, bootstrap the cluster and then do this thing afterwards, which relates to the app deployment as kind of an end-to-end thing. But, I'd look at other tools for maybe just the application side, like assuming you already have your cluster. That's just an option.
Okay.
Okay, awesome. Yes.
Real quick, we can get a picture.
Oh yeah, here. Let me pull my hair.
Yeah, 1, 2, 3, and digital.
Thank you.
Oh, really?
Oh no. Uh-oh.
That's fine.
Okay.
I know. Oh, I see. Yeah, I saw that you gave a top last year, so I was looking at it. Perfect.
Awesome. Thanks, Sean. Thank you.
Just
Hello.
one quick question.
Yeah.
Why didn't you cover the GitHub Action?
We were specifically looking at open source tools,
Oh, okay.
so we wanted to focus on different
okay.
open source tools.
Okay,
Yeah,
thank you very
no
much.
problem.
Yo.
It's been a while.
Indeed. How are you? Love your hair.
Yes, you know what? If they're not, we'll make sure to add them because I think we might have added them to the
No
problem.
just husband duties.
Yeah.
Hi, who are you? This is Michelle. Hey, nice to meet you. Yeah.
I love your sweater, by the way.
Thank you.
I was looking at it and I was like, how can I get one of those?
I got it because Muriel has this cool necklace, and I was like, wow, that's awesome.
Wait, what does yours say?
Engineer.
Oh, I need that.
Yeah. So I was trying to copy Muriel, but I got a sweatshirt. Yeah.
So cute.
Yeah.
I'm going to introduce myself. My name's Will.
Great presentation.
Thank you.
Oh my gosh, I feel like it was so dense, and I just want to review your slides over.
Oh my gosh, thank you. We gave a 30-minute version of this talk at KubeCon last year, and so we just went ham. We were like, we got a whole hour? Let's do it. And we were so close to finishing that demo. I think, anyway.
It was perfect.
Thank you.
Yeah.
I really appreciate it.
I feel like it was just like almost everything that I wanted to know.
Yeah.
And I'm a beginner, so I feel like it's going to take me some time to process it.
Yeah.
But it was great.
Awesome, thank you. You know what? I don't even think we got to the last slide. I put up I made a QR code, and I was like, if you send a thing, I've got stickers. That's what I did. I forgot. I made these stickers, and I forgot them back at
Oh my
home.
gosh, I was going to take a picture of it.
Yeah. Here,
Send it to my friend.
Are you on LinkedIn?
We have a lot of
Yes.
customers like
Yeah.
Who is not on LinkedIn?
I know,
That
right?
was like a silly question. I'm like, what's your last name?
It's Tyler. I don't know if you'll be able to find me.
Can we move this conversation outside?
Yeah. Let's. Oh yeah.
You've been evicted.
Thank you. No, it's good.
Yeah, I'll take that.
Yeah.
I know where she lives. Michelle, Matt, Michelle. This is a long time high school buddy.
Oh, nice to meet you.
Thank you so much. This was great. Thank you. Did you even realize that you had timing things over there until we were at 1 minute? And then I looked over and I was like,
Muriel
okay.
saw it. It's fine. It's totally
Okay.
fine.
I was just rolling.
No, it was great. I really wish you'd had more time. I was not bored.
Thank you. I couldn't gauge the crowd. You had so many people in here.
So I really suck at mirroring different things to project.
Okay. You should be able to just plug in and it should show.
Plug that in, right?
Yeah.
Yeah, so I need extra time to
Yep,
get
yep,
a hold of it. So, okay, so I don't need my connector, right?
So, that should work.
I recently went to a comedy show.
Let's see.
And
Yeah, thank you.
We're gonna break this up. My work office is in downtown.
I also want to.
Display menu. You should be able to.
I also want to be able to put my
Your talk notes?
not my talk notes. So the talk notes will be here. The speaker notes.
Yep.
It's perfect. But I also want to be able to share my console, my screen. So is there a way to have additional
I would
screens that I
put
can?
the console onto where your slides are, and then flip between. Yeah, that's what I would do. That's what I have always done.
Yeah, it's just going from Zoom on the slides to the console will take a little bit of time. Doable. That's my backup plan. And I wonder if there's a way to create another desktop right there. Is it something I can do?
Okay. I have never done this. Cool.
I just don't know how to get back to it.
Swipe up, 3 fingers up.
Okay.
Maybe?
Yeah. No, it's good.
Okay. If that works for you. Do you want to make that like as big as the screen, maybe?
Make it bigger.
Yeah, huge is good.
Hello, testing. Interesting. Is this working? Can you hear me over there? No, nobody can hear. Okay, let's try the other one. Hello, are we live on this mic? We are live on this mic. Excellent. Yes? Can you hear me in the back? You, can you hear this? No. What is happening? These are both not. This one seems, well, this has 3 bars and it seems a little low.
Huh? Yeah, I brought batteries, yeah.
Test, test.
Mine's done too. Okay, I'll change that one. Try this one.
Test, test. That one's worse.
Here, try it. Speak like a little bit more into it, yeah.
Speaking into the mic. Is this?
This one, that does feel really quiet. Okay, we'll stick with that one. Test, 1, 2. Test, 1, 2. Okay. Okay, I'm gonna change. Test, 1, 2.
Yeah, that one's been fine. Almost there. At least you don't have long hair.
Testing.
Yeah.
Test, 1, 2. Test, 1, 2. What? It works. I heard it.
Great. So what I'm going to do is I'm
Test, 1, 2. Test, 1, 2. And they're both off, so you each have to.
talking? Talking. Yes. I think. Yep. Should be. Hello, hello? Can you hear me? Excuse me in the back. This mic is still not live. I don't know what's happening. Oh, is it? There's 2 buttons. Testing. Yeah? I don't hear it at all.
Yeah, it's coming
Okay,
from the speaker.
very cool.
Okay,
You're
it's
just
just
in a speaker then.
the headphone. This thing is much louder.
This thing is just much louder, so.
So somehow. Like this? Yeah. It feels a little goofy. Okay. Yeah. All right.
Okay, awesome.
Okay. Hello, hello. Hi, everybody.
Testing, test, yeah.
You on?
Yep.
Okay, the power switch is up top.
Yep.
Yep.
Absolutely.
Hello, everyone, and welcome. I'm so happy to see so many people here. Thank you for waiting while we had some audio things to iron out. But now we should all be able to hear Kyle, who's here to give us a talk about build containers. And please give him a big hand, and welcome to SCaLE.
So, I want to make sure that this is going to be a useful talk. How much do you know about containers? Anybody knows how to build containers with Docker files? Okay, so we have people who know how to build containers with Docker files. Do you know how to build containers without Docker files? We have a few people who do. I'd love to know what you know. And I'm going to ask you if you know what we're going to cover. So the idea here is to explore different options, building containers, not only using the default Docker file-based way, which most of you know, but many other ways. Another question. Who knows what's inside containers? Like, just if you feel like you have an idea of what's inside, please raise your hand. And do you find it useful to learn more about what's inside? Okay, good. All right. I know too many questions, but I wanted to make sure that I talk more about the things that might be relevant and useful. So who am I? I usually don't talk about myself because you can always look online and it doesn't really matter. But I have created a tool that's pretty relevant. I'm the Docker Slim guy. I created Docker Slim to create minimal container images. But now it can be used to do many other things, including debugging those images. Actually, it's the only tool out there that allows you to debug images in Docker, Podman, Containerd, and Kubernetes. No other tool can do that, even on the commercial side. But one of the recent additions there is something that allows you to build, or what I call mint, regular container images. And it allows you to build and mint those container images the more traditional way, and it also has a few shortcuts, and I'll talk about that. That's the only reason why I bring it up, because we're going to take a look at the tool and what it can do. So first, I'd like to start with an experiment, and I'm going to try to run a couple of things, but because the network is not reliable, I don't know if it's going to work or not. So we'll see how it goes. Just in case, I have a few screenshots that we'll be able to discuss. But the idea here is that we're going to run a couple of apps. And it's the same image. It's the same Python image, the same app. It's a simple hello world. But we'll see different results. So let's see what happens there. Now, that might take a while, up to 10 minutes. The last time I tried to do it, it took 10 minutes. I was sitting right over there. In the hotel, it took a minute and a half. We'll see what's going to happen now. Now, if we look at the screen, we have a lot of stuff showing up, stuff loading, and I wonder if anybody wants to guess what's going on. Anybody wants to guess what's going on? Go ahead. Exactly. So we're pulling layers. We have an image that has many layers in it. And that image is kind of, the way I look at it, it's kind of like a tree trunk. you have circles, you have rings, one on top of the other, and you go through, like you load the first ring and then the second one, and you have to wait until you load all of those layers. And that actually shows one of the problems with the container images we have. They are built and designed around the build flow because you start with the first layer that you have initially, then you have the second layer on top of that you add, and another one. It's a great way to archive stuff, but it's not a great way to run stuff. And that's one of the problems. We have to go through the same sequence of stitching together the layers that we went through building the image. It was a simple design, and we're kind of stuck with it, unfortunately, and that's one of the side effects. Another problem with the images is that the layers themselves are opaque blobs. But let's take a look at what's inside the layers first. I'm going to leave this thing running, and I'm going to switch back to the slides. And then we'll come back and revisit. So first, I'll create a container image the easy way. I have a simple Go application. It's a statically compiled binary. And I don't need a Docker file. I can use a Docker file, but I really don't need to use it. And in my case, I'm using the Docker Slim tool with the Mint CLI to point to the statically compiled binary, and that creates an image for me. I'm going to try to recreate it. All right. All right. Let's see if we can repeat the steps. Build Linux. All right. I'll just copy this command. It's easier to copy. I created my binary. Right there, I just created it. 354. And then I just run mint image build, and I point at the executable. It's going to show a few lines on the console, and in a couple of seconds, it's going to be done. Right there, it's done. And if we look at the images, oops. Grab mint new. Yeah, we just got an image 28 seconds ago. And we can run it. Run it. Mint. Oops, yeah. I put the tar file name there, okay. All right, perfect. It's done. And let's see if we, okay, we're still loading. It's gonna take a while, but it'll be fun, I promise. So now we created an image. Let's go back. And we didn't use Docker files. And if you have statically compiled applications, that's probably the easiest way to do it. There are a few language-specific tools that do similar things. For example, if you use Go, there's a tool called KO that will compile the app for you, and it will do something similar to Mint image build here. But it is Go-specific. And there's another one for Java called Jib that does something similar. So we created a container. What is it in that container? I'm not going to use the same container because it was actually created in a not in a hacky way, but in a way that doesn't have all of the files in it that you would normally have. And I wanted to talk about the official container image spec and what's in it. And if you look at the spec, and I'm not going to cover the spec in great details, what you have there, you have 3 metadata files. Then you have a version information in a static file called OCI layout. And then you have a whole bunch of layers. Here I'm saving a Node.js application in a tar file. And in addition to those standard components, there's a couple of extra files like manifest.json and repositories. It is something that Docker uses internally, used historically, and they're leftovers from the old days, and they're going to be around for a little while, and then they're going to remove them completely. But they're still there. So you get the standard OCI components, and then you have the Docker-specific artifacts. And that's actually useful to know, and we'll be able to take advantage of that. So if we, let's see, can we go back? Okay, still loading. All right, so here okay, so let's take a look at the files themselves. All right. And it's still loading. All right. All right. So right there, I already have a saved copy, but I'll save it anyways. And you can get an image, a container image from your runtime from Docker, for example, by using the Docker save command. And I wonder how many people have done it. Have you saved a container image? And have you looked what's in that container image? Okay, so this is what we're going to look at next. We're going to take a look at the tar file that represents the data from that container image. So what do we have inside? We have those metadata file at the top level, and we have a whole bunch of so-called blobs. And those blobs are opaque data files that are layers, or they're manifest files, or they're config files. And they have funny names. And do you know why they have those funny names? I wonder if anybody can guess. Yep, yeah, exactly. Those funny names are SHA-256 hashes for the content of those files in that blob directory. And why? Why do we use those? Exactly. If something changes with the file, for example, the manifest file points to an updated config file, the config file content will change, so its hash will change, so its name will change, and because of that, the manifest file will change. So it's not like you're using this static config file name that wouldn't know what happened. Because you're using the hash value for the name, you know when something is different, and then it has a ripple effect through the rest of the files that reference the data. All right. So, oops. I already extracted what's in that tar file. Oops. And if we take a look, yep, that's what we pretty much have there. And if we look at the at those blobs, you can see based on their sizes, you can kind of guess where you have your layer file, 90 megabytes. It's probably the layer file. And the other files are metadata files, and we'll find out. So how do we know? And the index.json file allows us to know that this is one of those files is the image manifest file. So what is the index.json? You can think of it as a library catalog. I don't know if anybody used the old school manual catalogs, those boxes you pull out, you get those index cards. It's kind of like that. It tells you where your book is, and specifically the image manifest. All right. Get index.json. And here, this catalog tells us that we have one manifest, one image manifest that represents our book or image. That's an architecture-specific entity in our case. And that manifest has a digest, specific digest, that we'll be able to use. It doesn't have a name, a file name, but we can take the digest and we can guess the file name based on that digest. So it starts with 4402. So if we get that file, we're going to get the image manifest that tells us how this image is composed. And based on that information, that's how the runtime knows how to put together the image and then how to run it. So here we have the layers that we need to use in that image. And not all of the layers and not all of the blobs that are in the tar file are going to be used, because in some cases you might have multiple images. For example, when you have multi-architecture images, you might have a bunch of layers for AMD 64 or ARM 64. So here in the image manifest, it tells us a subset of the blobs that we want to use for the layers, and also the runtime parameters that we need to use in the config blob. And if we look at the config blob, one of the most common runtime parameters is the entry point, because without an entry point, we don't know how to run it. There is a lot more than just the entry point there. We have the environmental variable information, the labels. We do have the entry point. We have this funny looking section called rootfs with these diff IDs. Anybody knows what diff IDs are? Only a few people know, and you shouldn't have to, but it's a different way to represent the layers. And you also have hashes there, but these hashes are not necessarily the same hashes you would see 4961. You would see here. Here, in this case, it's the same hash because we happen to use uncompressed layers. But if the layers were compressed with gzip compression, so if we look at the media type, it just says it's a tar. But if it said tar plus gzip, then the layer would be compressed, and this digest would be different from the diff ID digest. It's a little odd how it's done, but that's how it works. So there's a bunch of information in the config file, and some of it we absolutely need to have. Other information, not so much. But it is the runtime related information we need to have, including the layers that we need to use when we're executing. So let's get back to the download. It's still loading. It's going to be this common recurring theme where we're going to be checking to see if it's still running or not. So that's pretty much what you have in a standard image. You have those 3 metadata files. You have like the index.json that tells you that's the starting point for your journey to get the rest of the metadata files, and then you have those hash-based files in the blob directory. And based on that information that we looked at, we can technically create a container image by hand. And it's not rocket science, but it is quite a few steps. If you look at that, it barely fits on one page, and it's kind of busy. And it's relatively straightforward. Obviously, you need to have your layers, but then for the layers, you need to put them in a tar file and then potentially put them in a gzip file. If you want to compress things, then you need to generate SHA hashes, you need to calculate the file sizes, because the file size information is referenced in those metadata files. And then you need to change the names, because after you create a layer, you need to calculate the hash. Then you change the layer file name to match the hash that you just generated, and then you do the same thing for the config file, for the image manifest, and ultimately something similar with the index. Again, doable, but that's a lot of work, and the question there is, can we cheat? And is there an easy way to build a container image by hand? And the answer is yes, there is an easy way. And the clue there lies in some of those extra files. There's a couple of extra files that are not in the official image spec. Manifest.json at the top level, and repositories. You can ignore repositories, it just has the container image name in it. But the manifest.json at the top level is something interesting. We'll take a look at that. So let's see. Okay, it's still loading. All right. And we're gonna go cd static by hand. Go app. Okay. So this is where we want to be. If we take a look at the manifest, I'll quickly show the content. It's not too complicated. It has a field that points at the config, just like the image manifest. That's good. That's a good sign. Then it has the tag information, and then it also has layer metadata, and again it references the hash name of the layer that we have, and it also has this layer sources metadata that we can ignore. So if we look at what we have in this directory, we have the bare minimum of the files we need to have to create a container image. Only 3 files, no funny looking hash named files, everything at the top level, humanly readable. You only need to deal with 1 hash, and that's it. So let's take a look at the manifest JSON here. And if we compare the standard manifest and this one, it's a subset that references the config file we have, and it's a simple name there, the name of the image that we want to have, and the layer file name, also a simple name, and that's pretty much it. And if we look at the config, and we don't need to hunt for it in the blobs directory, it's at the top level. We just have the funny looking rootfs section that references the layers that we need to have with one digest. That's the only digest we need. And then it has the entry point information and nothing else. So it's much smaller as well. And creating the layer, and because it's a static binary, creating a layer involves tarring my executable file, and that's pretty much it. I wonder if anybody knows why I had to use that tar flag, no X attribute. What? Yeah, exactly. So it turns out that there's, by default, if you don't pass this flag, you're going to end up with the extra macOS specific attributes. And that breaks the Docker runtime. It gets confused, and it just doesn't know how to handle them. It's a new quote-unquote problem. It's a side effect of them validating the attributes and not necessarily handling the attributes they should ignore. So that's why I edited. I had to edit, otherwise it wouldn't work. Yep, yeah, exactly. Exactly, exactly. That's the point. And if we look at what's inside this tar file, just the app, that's it. And then I'm going to calculate the hash of the layer.tar file, and that's the only hash I need to use. It changed. So I would need to update. Right. I would need to take that, otherwise it's going to break. And I'm going to change it in the config file. Right there. All right. So now we're going to compress everything we have. It picked up the macOS metadata files just for the fun of it. I didn't want to remove it. Those little quirks are always fun. And then right there we ended up with the image data tar file. And I'm going to load it into Docker. And it said that it loaded the image. And if I run docker run app container by hand, it's going to print the output. It's a simple hello world, but we just went through this flow where we manually created an image by using tar, SHA-SUM, and docker load. That's pretty much it. No specific container tools. So let's see if it's still running. No. Finally. That took a while, right? Okay. Now I'm going to run the other command. So this is the second command. It's very similar. Again, it's the same Python container, same Python version, pretty much the same application, a basic print hello world, but it's using this funny looking snapshotter parameter, and it's setting it to *GZ. And I'll talk more about it, what it means and what it's doing. Let's see how long it takes to run this application. It's going to be more than a few seconds, unfortunately, because the internet is a little slow here. All right. It might take about 45 seconds, maybe 60 seconds, but we have time. Let's give it 10 more seconds. And we'll see. Almost. Okay. It loaded the layers, at least a subset of them, and we'll talk more about what it means. Again, the network is slow. Yeah, so here I'm using a lightweight container runtime that uses the Lima VM, and it uses the containerd profile template, which is kind of the stripped down runtime. With Docker, you have all of those Docker components, but one of the components is containerd, and this is a lightweight version of it with additional modules that have additional capabilities, including lazy loading. This is why I'm using it, because it has what they call snapshotters, which is a way to support different types of behaviors in containerd. So here, if we look at the time it took to run this version, 1.5 minutes versus 18.5. That's a huge difference, right? That's a huge difference. And it is the same Python, the same app. How do we build something like this? And how does it work? Okay, so we just built a regular container by hand, and we saw it running. Great. So it wasn't impossible, and we could cheat. I love shortcuts. But after doing all this work by hand, I want to go over a few other options, a few other easy options that you can use. I'm not going to cover everything. Some of the other options are more involved, and if you're using Docker, you're using BuildKit behind the scene, and it doesn't really make sense to go into the BuildKit interface directly. It's just more complicated. I'm not going to torture you with Nix, because there is a separate Nix track, Nix Planet, on the other side, or maybe there. And a few other options like KO and Jib I already mentioned. They're language specific. And then you have things like Kaneko that allows you to build container images in Kubernetes. And I don't know if anybody's talking about that when in any of the Kubernetes talks, but possibly. And obviously there are other runtimes like Podman. But it's pretty much the same thing as Docker with a number of bugs in it. Compatibility related bugs. So it doesn't make sense to talk about those. So let's take a look at the easy options. The number one option out there that probably most people will know is build packs. How many people know about build packs, and maybe you've heard about it a little bit? You've heard about it, right? What did you hear? Good things, bad things? Ah, I see, because there are quite a few support articles for Google Cloud, how to use build packs, Google Cloud build packs. All right, that's a great way to learn about them. Do you know the history behind build packs? Anybody knows the history there? Anybody used Heroku in the past? Okay, we have a Heroku user right there. So the idea of build packs came from Heroku. And initially it was an internal construct where you would have code. With Heroku, the awesome thing about it, like it was probably the hottest platform as a service solution 10 plus years ago, where you could just have your code in a Git repository, then you do Git push, and then it would take care of the rest. So it would take the code from the Git repository, and it would figure out which application type you had, the language you would have, and then it would pick the right builder. That's where the build packs came from. So that they had that build pack construct internally, and then later on it ended up being externalized and adopted by other providers. And right now we have 3 providers. Heroku, naturally. Then we have Google with their own build packs, and we have build packs from Cloud Foundry. I don't know if anybody used Cloud Foundry, Pivotal, VMware, and all. So if you ever needed a private pass, that would be the route you would take, and that's the kind of build packs you would use. So that's the origins of build packs, and the idea there was to transparently build your application and then you deploy it. And with the container phase of cloud native, that means building the application and putting it in a container image. So you end up calling the build pack CLI and selecting the build pack you want to use, and it builds the image, the container image for you based on its detection logic. So internally, it has a set of detectors that look at different properties in your code to see, oh, I see package.json, so it must be a Node.js application, or I see, I don't know, go.mod, it must be a Go application and all of that, and it would trigger the build packs that matched. But unfortunately, just like we saw, there's not a lot of adoption there. For different reasons. I wonder if anybody has any guesses why. I'm not saying that there is one answer. You use them. Do you consistently use them, build packs? Like Google build packs, or you just try them and then like, I'll do my thing that I'm used to? Yeah, exactly. For a lot of people, it all comes down to the fact that you have all other things that you might want to do, and build packs are kind of like black boxes. And technically, you can customize them. You can customize the image that's used to build the application, and then you can customize the image you use to run the application. But you end up fighting with the layers of abstraction and opaqueness, and yeah, some people don't have any good things to say, but for others, it's okay. For simple apps, it's actually good, and the pack builder suggest command is probably the first command I would recommend running if you don't know anything about build packs, because it'll tell you which build pack to choose. Yeah. But with build packs, you're not limited to Heroku. So here you end up with containers that are built for you, and then you deploy them anywhere you want. So unlike the original version of build packs where you had to use Heroku, here you don't have to, because you end up with container images. They just happen to be these opaque blobs that you don't necessarily understand and you don't necessarily control very well. I'm not going to run the commands manually because we're kind of running out of time. I'm going to quickly spend a few minutes on the next option, NIC specs. Anybody heard about NIC specs? Probably not. Anybody heard about Railway? Okay, we have somebody who's heard about Railway. So I'd say Railway is next generation pass. Kind of like Heroku back in the day, but with new ideas and a lot more powerful. The stuff that they're trying to do now, they're trying to own the whole stack with bare metal data centers and all of that, optimizing every step of the flow. And one of the tools they have in that flow is NIC specs. It's supposed to be a replacement for build packs. So it's easier to build. And if you run Nix packs, if you try to compare how long it takes to build with build packs versus Nix packs, usually with Nix packs, it's much faster. And the downside of it is that you end up using Nix packages. And for some cases, it's totally okay, but not always. And I know Railway is trying to address some of that, and there are ways to provide custom APT packages, but it gets messy. So let's see. All right. Let's go to one of the other directories. And I'm using a different demo there, mostly because both build packs and Nix packs expect certain things from your application. For example, if it's a Node.js application, they expect you to have package.json that has scripts section in it, and it has the start script section. If you don't have it, and you try to run the build pack, it's gonna fail and it's gonna throw its hands in the air and say, I don't know what to do with it. So you either need to configure the application in a way that the build pack or the Nix packs expects, or you need to define the proc file. I don't know, you used Heroku, right? Do you remember proc files? No, don't remember? It is a file that you would need to define where you declare the executables, the processes you run when you deploy. So it's a leftover from the Heroku days. So you either define the proc file or you structure the application metadata in a way that Nix packs and build packs expect. One cool thing about Nix packs is, but it's a hidden feature, it generates the Docker file for you. The gotcha there is that you're still dealing with Nix packs. If you look at what's inside, you have all those Nix packs, Nix something something in it, so you need to know a little bit about Nix there. But at least it generates a Docker file, and it provides some transparency compared to build packs. So one of my favorite things to use is Nixery. It's my favorite thing to use when I need to debug an application. And I need a custom image with tools that I need for that specific debugging session. And the way it works, you simply say which packages you want in your image, and then it creates it for you. Behind the scene, it uses Nix packages, and you can discover the packages in that, through that search page. Let's try to run it. Yeah. It's cheating. Docker, images, grep, Nix, actually. Yeah. So we have that image. Yeah, it doesn't load instantly. I'm gonna force. Okay, good. And I'll try it again. So it's gonna take some time to load it because it's building that image on the fly. And if I needed another, and I got my bash console, and I can just curl Google from there. All right, great. great for debugging. And the debugging interface in the Mint toolkit allows you to use Nixery there as well. And that's one way to do it. Another tool that's similar to Nixery is ContainMe. I don't know if anybody used that, but it's more like a hobby project from somebody working at ChainGuard now. He used to work at Red Hat, now he's working at ChainGuard. You get to do the same thing, you specify the packages you want to use, but you get to use different packages. You don't use Nix packages, you use Wolfie image packages that are closer to what you would normally use in a Debian environment. They used to use Alpine packages, but because they built this Wolfie image ecosystem, they switched to use Wolfie packages. Now, getting back to that first slide where we had two applications, two Python applications. One took, tens of minutes, and another one a minute and a half. How can we build containers that load faster with the same data in them? There are a few options that we have available. And the first two, eStarGZ and Sochi, are the most usable options and the most compatible options. The other two, they use image formats that are not compatible with the modern and widely used runtime. So it doesn't really work with Docker. But if we take the images used for eStarGZ and Sochi, we can use them with Docker, even if Docker doesn't understand them. And with Sochi, that's something that AWS created, and it's available in a number of services there. You're using the exact same image, no changes whatsoever. And with eStarGZ, you do need to have a few extra things, but they are done in a compatible way. So if your container runtime doesn't understand the eStarGZ enhancements, it's going to ignore them and it'll run it just like a regular container. So what does it mean? If we look at containers and the layers that we have there, they're blobs, opaque blobs. They're normally tar files, and they could be gzipped, so they're compressed. But that's a problem, because it means you need to load all of that layer in order to get to the file you need. And that's what things like eStarGZ solves. It solves two problems. It allows you to know what you have in the layer, so it's no longer an opaque blob, and it does it by using this table of content construct with like right there, it's a file called stargz.index.json. So it introduces this index concept for the layer where it has the information about what's in the layer, and it solves another problem. It chunks the layer into pieces, and these chunks are wrapped into gzip, not containers, in gzip blobs, and then in that index file, you have the offset in the layer where the chunk is available, but the file you need to access. And it has the hash data for the file and the chunk and all of that. So now we have random access, random read access. So we no longer need to take the whole layer, extract it just to get to a file you need. There's a way to look up a file and only that file. So there's one more thing. In addition to the index file for the layer, there's this prefetch label, and it's a special feature in eStarGZ that allows you to tell the runtime that certain parts of the image need to be loaded first before everything else. So where did it come from? Where did eStarGZ come from, and what does it mean? So the name itself has a couple of ideas encoded into it. The S in eStarGZ stands for seekable. So that's the whole idea of making those opaque image layers accessible for random I/O, read I/O. So you can seek to a particular file that you need to access. And the E stands for extended, because the original idea behind StarGZ came from an idea from Google called container file system. And eStarGZ extended the idea and introduced a number of enhancements in order to make it more reliable and improve the performance. So the last thing I wanted to mention is how you can actually build that container image. And there are a few options. You can actually use Docker and BuildKit, but it's a little more involved and you need extra configs. The easiest thing to do is to use nerd control in Lima. So there's a way to just call the image convert command in nerd control, and it will take a regular image and it would rebuild it and add the index to it and chunk the layers, and then you'll get the new image format. And then inside you'll have all of those extra files. And if your runtime doesn't understand the index file and the prefetch metadata, prefetch marker, they'll just show up as regular files. And I'll show what I mean. All right. All right. So if we look at them, I don't know if we'll be there. They're going to show up in your file system like extra files that you'll be able to browse to. And right there you have the index table, and from your perspective it's just an extra file that you don't care about, and that's it. And here we have a couple of landmark files. One is used to indicate that we don't have any special files that we need to load first. Another one is used to indicate that we have special files that we want to load. I have a couple of other screens. So right there. All right, so here, an example of a layer where I don't have any special files that I want to load ahead of time. So I have the no prefetch landmark file as the very first thing in my layer, and the index file as the very last thing. Same here. Now here, it's a little different. Now I have the other marker, prefetch landmark marker. So the files before that file, they get loaded first. And the rest of them will be loaded on demand. Technically, they're just loaded in the background, but if you need the files after that marker, before that happens, we do a lookup in the index, then we grab the offset, and then based on that offset, the runtime will make an HTTP range request to the registry with the offset information that indicates the chunk, the layer chunk that needs to be fetched. Then the chunk is fetched, and then it's loaded through the fuse file system, and then the file that you need to access is loaded in the runtime. And that's pretty much it. It just shows the same index table. Thank you. So we have 4 minutes for questions.
Yeah, do you have questions? I will bring you the microphone so that we can put it on the record. I see a hand back there.
Hi. You mentioned that the tar layers in your image could be compressed with gzip. Is there a way to do that? I don't think Docker save does that by default.
Do you mind if I come over so I can hear you better? Okay. Can you say it again?
So when you use Docker save to make a tarball, obviously you could gzip the tarball yourself, but is there a way to gzip each layer in it? Because I think by default they're just tarballs inside and not.
So it actually depends on the mode you're using. If you use the Docker desktop, the current version, there is a flag there that you can check to use the containerd store. If you check that, the layer images will be gzipped. And if you don't, you end up with tar-based layers. Or were you asking about that output from the Docker save command?
So the storage registry that you're using for your Docker daemon is what determines whether each layer in your tarball is compressed or not?
Yes and no. Normally it's defined by the image itself. So you have an image in the registry, and if that image says the layers are compressed with tar and gzip, then that's what you're going to get. But if your native layers were tar, they're not going to be converted. There's a way to convert them and all of that. So ultimately it's driven by how the image is defined, and it's how it's stored in the registry. Yes. For that, if you're doing it by hand, then you would need to tar and then gzip. If you're not doing it by hand, you're using the regular tools, then it'll do it for you. By default, if you're building OCI images, by default you end up with tar plus gzip layers there. And you need to do a little extra to get just plain tar layers. So you're either not doing the pure OCI images, or you're doing extra hacky things.
All right, I think there was one more question over here. Somebody raised their hand. Oh.
So going back to your example where you built an image manually, you already had the blobs, right? You saved the blobs. You didn't build the blobs.
Oh no, I actually, if you look at the steps that I went through, I created the layer there. So I built my application, then I tarred that application, and it was the only thing in the layer.
Oh, okay.
That's it. So it's the bare minimum, the MVP of containers.
Okay.
So that's as small as it's going to get. But if you have a more complicated application, obviously you would need to add more stuff to that tar file.
Got it. So you had one tar ball that you tarred yourself.
Yep.
Okay. So last thing, so you had two files, right? You had the manifests and you had the repositories, and that's all you needed to.
Two files, manifest.json at the top level and config.json at the top level. That's it.
Okay. So there were no repositories in there at all.
Yeah.
Okay.
Yeah. Three files, one layer, tar file, and two metadata files.
All right, I think we're at time. Thank you so much, Kyle. That was super fascinating.
You. Hello, can you hear me? Testing, testing. You okay on this one?
Hey, hey,
Testing,
hey.
testing, 1, 2, 3. Testing.
Hey, 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 hey.
Keep on.
You two sound good, so do this one.
Hey, 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 hey. Yep,
Testing,
yep, yep.
testing.
Hey, hey, hey.
Testing, testing.
Strength, leadership, power, authority.
Do you hear anything?
Guidance, patience are God's gift to us as men. We have to cherish that, not abuse it.
Okay, so it sounds excellent on the feed right now. So the next thing we need to do is talk through your microphones and set the
Should I also be hearing the computer audio right now?
So, since it's just one signal, I just need the base level to come through, because after everything sits all night, we have to kind of check it.
Sure.
Hello, hello.
At this point,
Hey, hey, hey. Hey, 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 hey. Check 1, 2, check. Hey, hey. Yep, yep, yep. Hey, hey, hey. Yep. Is that really hot or a little bit down? Check. Hey, hey, hey. Yep. Yep. You want to control it on your end? Hey, hey, hey. Yep. Check 1, 2. Hey, hey. Hey, 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 hey. Hey, hey. Yep. Yep.
so we are now in a place where I would call it good enough, because I got to run through and check all the rooms tomorrow, because people come in here and do birds of a feather and various things, and you never know what they're going to do.
Exactly.
All right, may I have your attention, please? Before you guys get started with infrastructure as code, 3 ways. I'm Fossil. I lead the local cloud native Los Angeles chapter. We're with CNCF. If you happen to be local to LA, we do in-person events as well as live webinars. We are at community.cncf.io/chapters, and you can find us as Los Angeles. We'd love to have you guys on our in-person events. There's going to be one in April. Thank you.
Hello, welcome. Thanks so much, everyone, for having us here today. Anna and I are super excited because this is our first SCaLE ever, so yay! Thanks so much for inviting us. So we're gonna dig right in because we got some cool stuff to talk about. And I'm gonna start y'all off with a story. Who doesn't love a story? Okay, once upon a time, there was, in a land far, far away, a platform engineer named Inez. And she lived in the land of cloud native, where she was surrounded by all sorts of amazing tools. Things like load balancers, serverless, containers, Kubernetes, and YAML. And one day, she was sitting in her own home office, sipping her cup of coffee, and she looked around the land of cloud native, and she thought, man, things have really changed in the last little while. I mean, think back to the days before platform engineering was even a thing, and DevOps was just getting started. You know, our good old friend DevOps, which promises us continuous feedback loops, continuous collaboration, codifying all the things. And, you know, after a while, we saw that software was eating up the world, starts to take over our daily lives, and we needed a little something extra, right? And so Site Reliability Engineering, or SRE, was born, where not only did we care about those DevOps principles, but we also cared about something extra, right? We have the additional focus on customer impact and reliability. But of course, software never sleeps. The world continues to evolve, and we needed a little something extra beyond that. And this platform engineering was born, which again is deeply rooted in those principles of SRE and DevOps, but we have the additional concern of the internal customer, i.e. the developer.
We mentioned Inez is a platform engineer. What is a platform engineer, and what is it that you have to do? Nope. No? Hello? Testing? Yay, I'm actually live now. So Adriana mentioned Inez is a platform engineer. What is a platform? What is a platform engineer? A platform is an integrated set of tools, services, and practices. This is designed to support the development, the testing, deployment, and management of software applications. And the goal of a platform is to abstract away the complexities of infrastructure. This allows developers to focus on writing code and delivering value to users. And as part of her job, she had many tasks to do. She had to provide self-service capabilities and tooling, therefore giving developers autonomy while providing to them guardrails. She also had to make sure that her systems were observable and ensuring the health and providing troubleshooting capabilities as well. She also had to secure the systems, and that includes access controls, implementing security policies, certificates, and compliance monitoring. She also was focused on improving developer experience, which we're going to be calling DevX. DevX is all about how developers feel, think, and value the work that they do. With a lot of this work, she also had to automate a lot of repetitive tasks, including infrastructure provisioning, application deployment, security policies, and this ensured that the systems are consistent and processes are repeatable, back to those DevOps principles that we talked about. And lastly, she had to provision infrastructure. And as part of doing that, she had to ask herself, what is infrastructure as code? Infrastructure as code, which we're referring to as IAC, is what Adriana's going to cover.
Trying to steal my slides. Thank you. So infrastructure as code is the process whereby infrastructure is provisioned and managed using code and software development principles. So what are these software development principles? We've got things like everything as code, as the name implies. I'd be surprised if it wasn't. We want to make sure things are scalable so that whether you're provisioning 1 Kubernetes cluster, 20, or 200, it's still the same experience. We want to make sure that things are reusable and repeatable because let's face it, we are lazy and nobody wants to go clickety-clickety on a keyboard when we can just write it once and do it many times. We want to make sure that things are compliant and secure because nothing sucks more than having some nefarious actor going into your systems and wreaking havoc with your beautiful work. And finally, we want to be consistent because no one wants to hear those 4 words, works on my machine. So you might be wondering, well, what tools is Inez using or considering for IAC?
She was very overwhelmed. The infrastructure as code landscape is quite large, and there's a few tools in the market that do this. We have HashiCorp's Terraform, we have OpenTofu, Pulumi, Crossplane, Ansible, Cradix, and we even have proprietary tools from cloud providers such as Google Config Connector, Azure Service Operator, and Amazon controllers for Kubernetes. So what tool is better? What are the differences? There are tons of tools out in the market, and what do they do? What are the things that we're going to be focusing on today, and which ones should you use? But first, you might be wondering, who are we, and what is it that we're talking about? And, well, you already know what we're talking about, but why are we the persons that should be giving this talk? Well, we're here to help Inez and you make sense of the type of tooling out there that can help you make a more informed decision for your infrastructure as code needs. So I'm going to be introducing Adriana. She's a CNCF ambassador, a former HashiCorp ambassador. She's also a blogger, a podcaster, an O'Reilly author, and a maintainer of the OpenTelemetry end user SIG. She currently works as a principal developer advocate at Dynatrace, specializing in observability and open source. And when she's not coding, she's a lover of rock climbing and capybaras.
Oh, thank you, Autumn. And I'm going to introduce you to Anna, also known as my former work wifey. We used to work together as developer advocates at Lightstep, and sadly no longer, but we're still getting to do talks together. So Anna, like me, is a CNCF ambassador. She is also a member of the OTel end user SIG. She is one of our approvers. She is an expert in chaos engineering and platform engineering. And in addition to that, she enjoys fun makeup looks and Latin cooking. And of course, one of my favorite things, Anna always sports really dope-ass earrings to conferences. Oh, and I should mention, she is a staff developer advocate at Upbound. Now, I want to address that point in particular because one of the tools that we're going to be exploring today is Crossplane, which was created by Upbound. This is not a sales pitch. We are here to basically show you 3 cool infrastructure as code tools, present them, and it's up to you to decide which one you like and best suits your needs. So I just want to put it out there. And without further ado, let's dig in.
Now we wanted to give you an overview of understanding the infrastructure as code landscape a bit more and what tools there are in the space. We chose 3 different tools that do the same thing, but they all take different approaches on how they do these things. So first, we're going to get started with the first tool, which is OpenTofu. OpenTofu is an open source project under the Linux Foundation and currently has an application with the CNCF to be a sandbox project. It is a fork of HashiCorp Terraform 1.6, which means that everything you've written in Terraform actually is going to work. This project is supported by many companies such as Gruntwork, Spacelift, Harness, M0, SCaLE, and others. This project got created after HashiCorp changed Terraform's licensing from Mozilla public license to business source license in August 2023. The first version of OpenTofu is version 1.6 Alpha 1, which was released in October 2023. It has a declarative approach for provisioning cloud infrastructure, meaning that it specifies a desired state. It does this using HashiCorp's configuration language known as HDL, which looks a little bit like a love child between JSON and YAML.
Okay, the next tool we're going to look at, as I mentioned before, is Crossplane. Now, Crossplane is a CNCF incubating project, and it was created by Upbound. Now, one of the cool things about Crossplane is that it extends the Kubernetes control plane, and so as a result, it does things in a Kubernetes native way, so using stuff that we all know and love, like kubectl and YAML. Now, because of its tight integration into Kubernetes, one thing that it does is that it saves us from ourselves by managing configuration drift through Kubernetes reconciliation. And what I mean by that is, say you provision a VM in Google Cloud using Crossplane. And then you're like, you know what, I'm just gonna go into the admin console and change that up a little bit. And Crossplane's like, no, bad human, don't do that. And it'll say, that state that you've just introduced is different from the Crossplane state. We are going to revert that. So it saved you from your own idiocy. The other thing is, it can manage more than just Kubernetes resources. It is API-centric. So if it has an API, it can be managed by Crossplane. Now, this is an interesting thing that makes it different from the other IAC tools that we're looking at, because Crossplane is more than just an IAC tool. I'd see it as more of a more full-fledged platform engineering tool that can do all sorts of cool things. So that's something to keep in mind also when you're choosing your IAC tools.
And next up, we have Pulumi, our third tool. Pulumi is an open source tool created by Pulumi Corporation, which was started by some ex-Microsoft folks. Pulumi also has a paid offering. If you've used Terraform or OpenTofu before, Pulumi is going to feel very familiar because it has similar concepts like plans, state files, and providers. Unlike Tofu, it uses domain knowledge, doesn't use domain-specific knowledge like HCL. Instead, it has language-specific SDKs to define infrastructure language, and those languages supported include TypeScript, JavaScript, Python, Go, Java, and YAML. And there you have it. That's a bit of an overview of our tools. So now we're going to do a little bit of a show and tell. But first, we want to preface on what we're going to be doing. We have a GitHub repo with the examples that we're going to be going through today. There's a handy QR code here, and we also have this QR code at the end of our talk. First, we're going to be using the 3 tools to do the exact same thing, so you can actually do some pros and cons and like compare for yourself. We're going to be creating a GKE cluster. Then we're going to be creating a node pool and add it to the cluster that we just created. And to make sure that everything is good to go, we're going to test it by doing a canary deployment of Nginx. And when we're done, we're also going to nucleify the cluster and all the associated resources with it. That QR code has been has like the GitHub repo, which also links you to being able to run this in a dev container on GitHub Codespaces, or locally using VS Code Dev Container plugin. For example, it already has pre-configured installations for OpenTofu, Pulumi, and gcloud CLI. So thank you, Adriana, for setting that up.
Love dev containers.
So we want to set the stage and cover some terminology that applies to these 3 infrastructure as code tools. First, we have a provider. A provider is a plugin that allows infrastructure as code tools to interact with various APIs, cloud providers, and other services. Providers are responsible for defining the resources and data sources that the infrastructure as code tool can manage. Each provider adds a set of resource types and data structures that infra as code tool can actually use to create, update, and delete infrastructure components. Then we have state. State refers to the store representation of the current status of the managed infrastructure resources. This state is used to keep track of the attributes and relationships of those resources, enabling the infrastructure as code tools to determine what changes are needed to be applied for the achieved configuration to go through. So what are some of the prerequisites that we're going to be needing in order to run these examples locally or for today? Well, first, we're going to be leveraging Google Cloud, so you need to have a Google Cloud account. If you're wanting to create a new one, you can actually get set up with a new Google Cloud account that comes with 200 USD credits, and you have 90 days to spend them. If you're not running on your own account, you want to make sure that your Google Cloud account actually has permissions to run a GKE cluster and that you're authorized to do that. And ideally, in a real-life scenario, you also want a service account that has permissions to do all the things that you need to do. So to set up the project, you want to run a gcloud config set project to your project name, and you also want to log in to the gcloud auth with the gcloud auth login.
And now let's dig into OpenTofu. So for OpenTofu, to be able to run our project, we need the Tofu CLI, and we also need the Google Cloud CLI. And you can scan the QR code on your screen for installation instructions for OpenTofu for your convenience. Also, like I said, like Anna said, it's pre-installed in the dev container in our repo. Okay, so this is the file structure for our OpenTofu project. I'm just gonna highlight some cool stuff. First of all, notice that there's like some Terraform and .tf extensions because this was a fork of Terraform. So basically it's got all the Terraform nomenclature. So if you're familiar with Terraform, if you've used it, same thing. Actually, the example that we used for this repo was based on some work that we did a couple years ago. And lo and behold, it actually still worked. So color me impressed. All right, so first of all, we have this .terraform folder right here. And this is where all of your providers and external modules that you depend on get downloaded to. Next, we have the modules folder. And so this is where you define your OpenTofu modules. Modules are not mandatory, like totally optional, but for me personally, I'm a bit of an OCD coder and I like to, have modules for different types of things. So created a module for our Canary deployment and one for our Kubernetes cluster creation. Next, we have main.tf at the root of our project. OpenTofu/Terraform always looks for a main.tf file as the entry point into your OpenTofu code. We also have providers.tf. This is where we define and configure our providers. Totally not mandatory. You can honestly put it in main.tf if you wanted to, but it's just convenient to separate it out. Again, the OCD coder in me loves this. We have variables.tf. This is where you define your input variables. And then your hard-coded values for your variables go in here, terraform.tf vars. I get ignored it here because really you can fill this out with your favorite values. So again, these are hard-coded. And then outputs, this is where your outputs from your Terraform code go if you would like to reuse them for by some other Terraform code. And finally, we've got our TF state file, terraform.tf state. This is where our state gets stored. So whenever you are creating new infrastructure, it keeps track of the stuff that's been created. If you're making deltas, it keeps track of the deltas. When you're nukifying, it'll keep track of the things that you are deleting. So super important. So this is residing here locally, but if you've used Terraform, you know that you can also store your TF state file in the cloud through your favorite local cloud providers, such as AWS S3. So you have those options. Okay, so this is our main.tf at the root of our project. And we're going to look at a few interesting things. So first of all, this is where our modules are defined. So we've got two modules. We've got here Kubernetes cluster create, and it's located, the source for that is in our modules folder. And then we also have our Canary deployment module. And as you notice over here, it has this depends on attribute, and it says, do not run this until after I do the cluster create, because Terraform/OpenTofu doesn't care if you put this before this, it'll try to execute in whatever order. So unless you tell it that, wait here, buddy, we got to do this after, it's going to try to create stuff that doesn't, create stuff based on stuff that doesn't exist, and it'll scream at you, and then you'll spend hours and hours trying to debug it and get mad at it. Okay, next thing, the providers.tf. Remember that I told you that's where we put our provider configurations and the required providers. So our required providers are number one, Google. And as you notice, you can use the HashiCorp providers. So I just did. I used the Google HashiCorp, the Google HashiCorp provider and the Kubernetes HashiCorp provider. Google is so that we have access to all the stuff to create resources in Google Cloud, and then the Kubernetes provider is so that we are able to deploy stuff to our Kubernetes cluster. So you can specify like your Kubernetes deployments, namespaces, services, etc. In here. And then we also have the required version. So this is the version of OpenTofu that this applies to. We should version all the things because we all know that if we forget to version, and this has happened to me way too many times, if you don't version it and then you try to run your code, weeks, maybe days down the line, all of a sudden it doesn't work, and then you feel like all technology hates you. So always version. And then we have in here, we had our provider definitions. These are provider configurations. So here we're configuring our Google project, our Google Cloud info, so our project name and our region. We've got these 2 data stanzas here. These capture information for our Kubernetes cluster, which is important because that's required by this Kubernetes provider. So because we are deploying stuff to our Kubernetes cluster after we build it, but we have to know what cluster to deploy it to. And then we have the main.tf in our Kubernetes module. So this is the module where we're actually creating our Kubernetes cluster. And this is it. This creates our Kubernetes cluster. A couple of notable items here. So first of all, we are creating a node pool, a separate node pool as part of this exercise. So we're using this attribute here, remove default node pool. We're setting it to true, so we don't end up with more node pools than we care for. And then also deletion protection. So by default, if you leave this out, it defaults to true. It's the same as defaulting to true. And if you leave this out or set it to true, when you try to nukify your resources using tofu destroy, it will fail, it will not let you. So if you want to have any chance of destroying your Kubernetes cluster, you have to set deletion protection to false. And then next we have our bit that creates our node pool. And so notable things. First of all, we need to say, well, what cluster does this belong to? And we specify this here, right? So it's Google container cluster.primary.name, which, oopsie, too far. Where'd you go? Oopsie. Hashtag fail. Okay. Here, Google container cluster.primary.name. So that's how we know what cluster it belongs to. And then here we define some additional information about the machines that belong in our node pool. Awesome. And then going into our Canary deployment module, our main.tf, like I said before, we are deploying Nginx, so we are, first of all, creating a namespace. I hate deploying things to default. It's like nails on chalkboard to me. So we're creating our namespace. And then we are going to next deploy our Nginx. Now this is just a snippet of the resource creation for our deployment because it's kind of long and that's a lot of stuff to fit onto a slide. And so this is just part of it. And then we have our service definition. So then that'll create our Kubernetes cluster, and then it'll deploy create a namespace, a deployment, and a service in our newly created Kubernetes cluster. So once we've defined all the stuff that we want to create, then we do a tofu init, and this will basically download all of the providers and modules that your project depends on into that .terraform folder that we talked about earlier. You only do this once. Unless you change stuff around, then every time you update your code, update your providers, modules, external module dependencies, you do have to rerun that. Then you do tofu plan. So tofu plan will basically look at your code and say, hey, these are the things that we need to create. It'll give you a list. You're like, cool, that looks awesome. And then you run tofu apply -auto approve. Now, when you run tofu apply, tofu destroy, it'll always produce a plan as well because just to make sure, hey, are you sure you want to do this? If you want to skip the prompt that says, hey, are you sure you want to do this? You just use the auto approve flag. And then similarly in destroy, if you want to nukify, it'll nukify all the stuff that it created. And again, the auto approve will basically say, yes, you don't have to keep asking me over and over. And I want to mention really quickly, OpenTofu has a number of providers. Here are some, oopsie, noteworthy ones. And you can get the full list of providers by scanning this QR code. Honestly, the providers page is kind of crappy. You can probably get a better feel for the providers by going into the Terraform providers, because those will work here too. Okay, cross-plane time.
Sweet, thanks for that overview. Now we're going to do a very similar demo of how it works with Crossplane. First, we want to go through the prerequisites that we need in order to do this on Crossplane. First, we need to have a Kubernetes cluster. We're going to be leveraging a Kind cluster for this example. You're also going to be needing Helm to install Crossplane. We're also going to be using kubectl in order to manage resources and apply the things that we're going to be creating. We have gcloud also set up to interact with Google Cloud. And lastly, we're going to go ahead and assume that you have a service account that has already been created for this example. But first, we want to define some terminology on how crossplane is a lot more different than the tools that that we're also explaining on this one. First, we have to define control plane. Control plane is how crossplane extends the Kubernetes control plane, and that means it's a management layer that enables the orchestration of cloud resources and services among multiple providers. It creates and manages the lifecycle of these resources, and rather than having a state stored in a file, kind of like some IAC tools do, it will constantly check the intended resources exist and report when the intended state does not match reality and reconcile to make things right. We also have compositions. These are declarative templates that enable the creation of multiple managed resources. An example composition creates a virtual machine, storage resources, and networking policies. Then we have composite resource definitions. Adriana mentioned that Crossplane manages more than just infrastructure. Anything with an API can be managed, and this is because of composite resource definitions. It defines the schema for a custom API to create a managed composite resource, and Crossplane XRDs are kind of like Kubernetes custom resource definitions. Then we have composite resources, which create composite resource. Composite resource definitions create composite resources, and these represent a managed resources as a single Kubernetes object. Then we have managed resources, which are the objects inside a Kubernetes managed resource, and an example of that is going to be the Google GKE cluster that we're going to be creating today. We also have functions, which are crossplane extensions that template crossplane resources. You can run a pipeline of simple functions to compose resources, and there's a crossplane community that has a whole bunch of a whole library of providers, functions, and configurations, so you don't need to create this from start. This includes things like Q, KCL, Helm-like Go templates, and you can write your own function using Go and Python. And lastly, we have claims. These are like composite resources, but with namespace scoping. This is how a user is going to request infrastructure without needing direct access to the underlying infrastructure configuration. And Crossplane also has a CLI that makes the creation of these resources a lot easier. So yes, that was a lot of terminology to go over. How does this all play together? Well, a user leverages a claim to create composite resources defined by these compositions and composite resource definitions. And these are also able to call providers and create managed resources. So let's take a look at what the structure of a Crossplane project looks like. These are the files that you're going to need to create a Google Kubernetes cluster. First, we're going to define the providers. So first up, we have the Google Cloud Provider. And then we also have the Google Cloud Container Provider that we're going to be using. It's just a simple YAML file that kind provider, and it calls in a package. And you're able to pin it to a different version if you need to. There's a whole library of this, including all the major cloud providers and a few other of the upcoming cloud providers as well, and other tools as well. Then we're going to be grabbing the credentials for the service account that we mentioned to have created, and that's going to be the GCP credentials.json file. Then we now have the credentials file, and we want that to tie into the actual configuration of the provider that we installed. So we're going to have a file for GCP provider config, which looks like this, where we define the configuration, and we give it the project ID that we're going to be using with Google Cloud, which in this case is Crossplane Playground. We're going to give it a namespace, and we're also going to give it the name of the secret for the Kubernetes secret that we're going to be using for storing this credentials.json. Now we have two other YAML files that define the cluster and that define the node pool. So we have the GCP cluster claim, which is another YAML file, and the GCP node pool claim. The cluster claim is something very simple where you're able to apply different configurations for it. So we're giving it the cluster name test cluster, and then we have some specifics on the way that we're going to interact with the provider. Similar to the OpenTofu example, we're going to be removing the default node pool, so we set that to true. And we also have a deletion protection, which means that if we want to delete the resource within Crossplane, we want to also delete it from the cloud provider. By default, is always delete. The other option that you have is orphan, which that means that Crossplane stops managing the resource for you and still leaves it up and running on your provider. The config for the GCP node pool claim allows for you to match labels and allows for you to define the way that you want it to tie into the cluster that you just created. And we also have node configuration, which allows for you to give it the type of machine types, more specifics on disk size and OAuth scopes that you might need, as well as apply other labels for it. Then the last thing that we have is an Nginx YAML file for the deployment of the test that we're going to be running, which just looks like a simple deployment file from a Kubernetes application. So first, we're going to start by installing Kind. After that, we're going to go ahead and create a cluster for cross-plane cluster using Kind. We're going to make sure that we're in the right kube config, so we're going to do a kubectl cluster info, change context to the newly created cluster that we have. And then we're going to add the repo for crossplane into our cluster. After we do that, we can actually do an installation for crossplane. And we also hate installing everything on default, so we're going to create a namespace for it, which is crossplane system. Next, we're going to go ahead and apply the provider for GCP provider. We're also going to apply the GCP container provider YAML file. And we're also going to grab the GCP credentials.json file from gcloud. After we have that, we can now create a Kubernetes secret using that JSON file and give it the name of GCP secret. Now we can apply the provider config, which lets you make sure that you're on the right account. And now we can go ahead and apply the cluster claim as well as the node pool claim and have these resources created. We wait a bit since creation of these resources within a cloud provider takes a bit, and we can do a kubectl get cluster and see crossplane managing our cluster. But we also get to see Kubernetes managing our node pool as well. So now we can actually grab the kube config for the newly created cluster that we have and do a rollout of our Nginx deployment. And we can switch back to our crossplane cluster and you can find the resources starting with the cluster claim and the node pool claim. And you can do a kubectl get clusters and get node pools to make sure that things are no longer created within your cloud provider. We have multiple providers within Crossplane, so that includes providers for OpenTofu, Terraform, Kubernetes, Helm, as well as cloud like all the cloud providers I mentioned earlier, and many others. You can head on over to the marketplace of all these providers.
Okay, and then finally, we are looking at Pulumi. So Pulumi, prerequisites, you need the Pulumi CLI. This next one is optional, an account on Pulumi.com. If you want Pulumi to manage your state for you, this is super handy, and it's free for personal use. Otherwise, you do have the option of managing your state locally, or again, as OpenTofu allows you to basically store your state in your favorite cloud provider's storage mechanism. And then finally, again, we need gcloud. So this is our Pulumi project. And I'm going to, in order to get this basic setup, there is some bootstrapping that you can do with Pulumi with the CLI. And it's through this command here, this Pulumi new. And essentially what it's doing is, first of all, because in this example, I love Python, so I'm using Python to provision a GKE cluster. They have these templates that are based on language and cloud provider. So there's a Python GCP provider, and when you specify this, it bootstraps all this, it scaffolds all the stuff that you need to provision Google Cloud Infrastructure using Python code. The name of our project, I called it IAC 3 Ways. -S is your stack, so Pulumi keeps state in these things called stacks. And the idea is you create a stack per environment. So you have one for your dev environment, one for your QA environment, one for your prod environment, etc. And then here is the -D is the description of our project. So we're provisioning a GKE cluster. And then -Y says, okay, skip all the preamble of non-mandatory stuff, just create me the things. Now, your other option for scaffolding a Pulumi project, if you already have something, and you want people to be able to reuse your code. Instead of pointing to one of their templates, their existing templates, you can point to an existing GitHub repo, provided that you have access to that repo. This is our repo. It's public. And then the other options are pretty much the same, except this over here, -force. You add this -force flag if you are running this command in a non-empty folder, because it will overwrite all the things in that folder with whatever is in here. And the same thing honestly applies to this other command. Same deal, if you want to overwrite the stuff in your non-empty folder, it will do that. Just buyer beware, that's what happens. Don't cry if it deletes your stuff. Okay. Now, let's look at the different things that are created as part of the scaffolding. So first of all, it creates this pulumi.yaml file, and it looks like this. This is the name of our project that we specified in the command line. Because we are doing a GCP Python project, so it's saying, okay, we're using Python runtime. By default, it uses pip and venv. If you're a poetry person, there are options for that as well. And then this is our description that we specified. Oopsie. In addition, if you're using Pulumi Cloud, then you would see your stuff created here. So this is our project, and then this is the stack. Also, we have a pulumi.dev.yaml. So dev represents our stack name. So if you had a QA stack, it would be pulumi.qa.yaml. So these are environment-specific configurations. So this is what your pulumi.dev.yaml looks like. First of all, there's some configurations specific to your cloud provider. So your project, your region, and your zone. And because we're using GCP, these are GCP-specific environment variables. And then these are environment variables that we're going to use in our Pulumi code, which we'll see in a sec. Next, because we said in our pulumi.yaml we're using venv, it creates a venv folder. It spins up a Python virtual environment, and it will also create you a requirements.txt with some of the base Pulumi GCP libraries that you require. Obviously, if you're doing other funky stuff or using other Pulumi libraries, you would put them into your requirements.txt. And then finally, it scaffolds a main.py for us, and this is where your IAC code lives. So let's dig into main.py. So first off, here are some imports from that we see in main.py. These are Pulumi libraries. They're GCP specific and ones that we require for creating a GKE cluster. Also, I'll point you to this QR code over here. This points you to the Pulumi examples GitHub repo. This is a great GitHub repo. It has all sorts of examples for different languages, different cloud providers. I used this when I was messing around with Pulumi 4 years ago. It was a lifesaver. Used it again when I was updating this code. Again, a lifesaver. So most of the code is poached from that. I made a few modifications, but it's mostly that code. Next is the config section. And as you recall, we saw in the pulumi.dev.yaml, we specified some variables. And in this config section, it pulls those values from that pulumi.dev.yaml over here. Yay, super handy. And then finally, this is the bit that creates us our Kubernetes cluster. And it's kind of funny that we see no matter which one of these IAC tools that we've been looking at, the basic structure remains the same. I mean, it almost looks like identical code because a lot of the fields are similar, right? Because we're using the Google Cloud GKE cluster creation API, it requires a lot of the same fields. So again, we are disabling deletion protection so we can nukify our cluster, and we are also doing this remove default node pool. One thing that I quite like is this min master version, which it's pulling from this engine version environment variable, which I want to point out over here. Super convenient here. It has this lovely function, which I like because I don't know about you, but every time I provision a freaking GKE cluster, it tells me that the version that I set is no longer valid, which is extremely irritating. And then I'm like, which one is it? Which one am I allowed to use? So super handy. Okay, next we have our node pool creation. So this is where we specify all of the information for creating our node pool. Keep in mind here, we have our cluster name. It's pointing to Kate's cluster.name, which was defined Kate's cluster dot, where is the name? It's not here, but it's implied. So we just didn't set that variable specifically. Okay, next, oopsie, keep doing that. Oh, and then the other thing is our node image, our node VM configuration. This is stuff that we pulled from our Pulumi configuration file. Okay, and then the next bit here, we are basically, once our cluster is created, we pull the output information of our cluster into this Kate's info variable, which we then feed into this Kate's config bit here. And this looks like a kube config file. This is a Kubernetes, a kube config file specific to Google Cloud because it's finicky and snowflakey and has its own thing. So this puts it into the Google Cloud kube config format. And what it's doing here, the Kate's info, we pull that information. We use that to create this kube config file. And then we use that Kate's provider, which Kate's provider pulls the information from our Kate's config file so that we have the information to basically pass in when we create our Canary deployment here. So it's saying, hey, we know what Kubernetes cluster to apply this to. So we're creating our deployment, and then our service, and then that is that. So that is Pulumi. And so to apply this lovely Pulumi code, you'll notice that some of the commands are quite similar. We have, this one's a little bit different. So first we have Pulumi stack select dev. This is saying, okay, you know, we've got a bunch of stacks that we define for Pulumi. We are using the dev stack so that we know that we're storing the state there. Then we do Pulumi preview. So that's similar, there was that similar command in OpenTofu. We have Pulumi up, which is similar to tofu apply. And then tofu had auto approve. This has -y. Pulumi has destroy. I believe tofu also had destroy, but -y with the auto approve. And again, up and destroy will also do a preview of the resources that you are about to change. And if you want to dispense with the pleasantries and just say, do it, I don't want to be prompted, the -y will auto approve. And then finally, we have some lovely Pulumi providers that you can check out. There's a Terraform provider for Pulumi, there's a Kubernetes provider, and there are, which we saw, there are various cloud providers, so I think most of the major clouds are covered off, and you can scan this lovely QR code for a full list of providers for Pulumi.
So now that you have a little bit of a full understanding of what infrastructure as code is, a little bit more of the infrastructure as code tool landscape, we want to give you a little bit of a recap and leave you with some thoughts on how you can go about choosing what makes sense for you to use. First, it depends very much what tool makes the most sense for you. So what is it that your team is trying to do? What is it that they're trying to manage? Are they just trying to manage cloud resources, infrastructure, or manage other APIs? And are you trying to build a self-service platform? You also want to ask yourself, do you want to be managing state files, or do you want to lean into Kubernetes reconciliation? What skills does your team have, and what is it that they're wanting to up-level or actually learn? And what is the community health for these projects? What resources is your team going to need, and can they lean on the community to actually be able to get those resources and ask for help? So if you're looking to take pictures of our slides, this slide and the next slide give you a little bit of a recap on the tools and like how is it that they differentiate from one another, including the language, the installation, state, and the support that they have from the open sources ecosystem. And the next slide is our list of pros and cons on the ways that we look at these tools on our own. And hopefully this gives you a little bit of an overview to understand what tool makes sense for you, because it very much depends. And for the spicy folks in the room, hopefully you saw some of the raccoon facts that we left in the slides for you to keep paying attention to this. Well, we chose raccoons because we think from the animal kingdom, they're the ones that would be coders, and they would specialize in social engineering because they love getting into places they shouldn't be. They love penetration testing. They love cracking locks and evading traps. They do recycling of algorithms, effectively scavenging and repurposing resources. And they also would be great at machine learning because they're rapidly adapting to new urban environments and learning from mistakes. And what's your fun fact about raccoon?
Oh yeah, my fun fact is, so I'm from Toronto, Canada, and the raccoon is our unofficial mascot because we have a lot of freaking raccoons in Toronto. I think there's like as many raccoons as there are people. It's ridiculous, so yeah. My claim to fame. Okay, so we leave you off with some handy dandy resources, including QR codes on how to connect with us. We are on Blue Sky, LinkedIn, Instagram, thinking whatever else, on all the things. Also, not related to this talk, but I do have a course on observability with OpenTelemetry for anyone who is inclined to learn about OpenTelemetry and has an O'Reilly subscription. We have a link to the repo, once again, that we used for this talk, and it's got the examples with all the code. And again, as Anna mentioned, we have it set up so you can run it in GitHub code spaces or locally with dev containers. I love dev containers, no fuss, no muss. Also, I have a podcast, and my daughter designed the logo. It has a capybara on it because I love them. And I've had some awesome guests on the podcast, including Kelsey Hightower, Hazel Weekly, who's sitting near the front, Autumn Nash, who's like my most recent guest. Anna has also been on the podcast. I've had Charity Majors, Liz Fong Jones, so all sorts of really cool people in tech. And Anna and I used to have a podcast together at work until they told us we couldn't do it anymore, and then we cried, and we have 2 lovely seasons, and you can still find it on Spotify, and it's got the greatest name ever on Call Me Maybe. And we also had some really awesome guests, so give it a listen. And finally,
in case you're wondering, all these images were generated by the AI because we can't draw, but we are great prompt engineers. So we do say a thank you to our evil AI overload, Bing AI, powered by DALL-E 3 for the images. And with that, we want to say thank you for sticking around towards the end of the conference and listening to our talk. Hopefully you learned something new on infrastructure as code or just in general of like technology tooling. So thank you all.
Thank you.
And we have about 10 minutes of questions here. I know you'll both be around too for people that don't fit in. Anyone have questions up front we want to ask with a microphone?
And I have crossplane stickers if anybody wants crossplane stickers.
Are they the popsicles?
Yeah.
That's great.
Ooh, they're great. And I've got capybara stickers. Ooh. Yay!
All right, so if there's no questions right now, you can go ahead and find them afterwards, and thank you so much.
Amazing.
Now you have a question?
How did you get so awesome?
Practice. being great.
Oh my God.
It was an incredible presentation.